Hello and welcome to the Snoozy Scientist. I'm really glad you made it here tonight. Wherever you are on this planet, this little pocket of quiet was made just for you, a calm space where science and stillness can sit side by side to put you into a deep sleep. Tonight, we're drifting into one of Earth's most haunting mysteries. For as long as Earth has breathed, it has carried a quiet rhythm, the slow pulse of creation and collapse. And in its 4.5 billion years of existence, life has come close to disappearing not once, but 5 times. These weren't gentle goodbyes, they were cataclysms, sudden, merciless resets where more than 3/4 of all living things vanished. Oceans lost their color, forests turned to ash, the air itself turned against life. The planet didn't just lose creatures, it lost entire ways of being. The Ordovician, when the seas froze, the Devonian, when the oceans ran out of air, the Permian, the Great Dying, when almost everything disappeared, the Triassic, when fire remade the continents, and the Cretaceous, when an asteroid ended the reign of giants. Each time, the planet changed so completely that evolution had to start over. For generations, scientists believed these disasters belonged only to the deep past, ancient accidents that could never return. But lately, that rhythm seems to be returning. Extinctions are accelerating. Species are vanishing faster than we can record them. Forests vanishing faster than they can grow back. Coral reefs are paling to bone, and this time, the trigger isn't fire or ice. Scientists have been talking about the sixth mass extinction, but what does that really mean? When did it begin? And if it's already unfolding, would we even recognize it while we're still inside it? So tonight, we'll trace this pattern through time. We'll search for the clues that Earth has left for us and ask the question that may define our place in its story. But before we begin, if you're already enjoying this peaceful moment, it would mean the world to me if you gave this video a gentle like, maybe even subscribed if you'd like more sleepy science stories like this. And if you'd be so kind, let me know in the comments where are you winding down from tonight and what time is it there. I love watching our little bedtime map light up, one dreamer at a time. So now, take a breath, let your shoulders soften, and let's begin. Every story of life is written in layers, sand, stone, and silence. When scientists read these pages, they do not find words but patterns. A curve of bone here, a layer of ash there, a line of darkness pressed between brighter ones. Each mark tells of something that once lived, and of a moment when it stopped. In those quiet records, a rhythm emerges. Most of the time, extinction is gentle. A few species fade away while new ones arrive to take their place. The balance holds. The loss of one kind of creature opens a door for another. This is the background pulse of evolution, slow, steady, and almost invisible when viewed across the vastness of time. But sometimes that rhythm stumbles. The curve that once rose and fell in calm waves suddenly drops into silence. These moments are what scientists call mass extinctions, the disappearance of at least 3/4 of all species in a geologically brief moment. To us, it might sound slow, unfolding over thousands or even millions of years, but in Earth's scale, it is as sudden as a storm. To understand such loss, scientists trace fossils as if following footprints through time. They study where life once flourished and where the record goes dark. A sudden thinning of shells and ocean sediments, a break in coral layers, a missing chorus of pollen grains in the rock. All of these are signatures of collapse. The more gaps they find in the fossil record, the clearer the story becomes. Something happened that life could not outrun. But fossils tell only part of the truth. In recent decades, researchers have turned to the invisible, the patterns hidden in DNA. By measuring the diversity of genes in living species, they can estimate how many branches of the tree of life have been trimmed away. Some lineages show scars from past crises, where generations were reduced to a few survivors. Others still carry echoes of abundance, their genetic roots stretching back through eras of calm. Through these clues, a picture forms. Life usually changes slowly. Species appear, adapt, and disappear over millions of years, a natural turnover that keeps ecosystems balanced. Yet when a mass extinction strikes, that gentle turnover is replaced by a sudden freefall. The difference between a normal extinction and a mass extinction is like the difference between a single candle going out and the night itself falling forever. One darkens a room, the other swallows the horizon. During these global endings, food webs crumble. When the plants vanish, the herbivores follow. When they fall, so do the predators. Even the smallest disruptions can unravel everything, because every creature depends on others it will never meet. In the past, the causes were always natural: a shift in temperature, a pulse of volcanic fire, the poisoning of oceans, or the fall of a single asteroid. But whatever the cause, the pattern that followed was always the same: collapse, silence, then slow renewal. Scientists measure the pace of these events in geological time. A typical mass extinction might unfold across a few million years, long enough for oceans to turn and mountains to wear down. Yet compared to the normal rhythms of evolution, even that is breathtakingly fast. The recovery, the return of complex ecosystems, takes far longer. After the Great Dying at the end of the Permian period, it took nearly 10 million years before the seas filled again with the color of life. When we compare those ancient spans to the present, something unsettling appears. The changes shaping our world today are not unfolding over millions of years. They are happening in mere centuries, and in many cases, within a single lifetime. Species vanish before they can even be named. Forests that took thousands of years to grow can disappear in the time it takes to build a city. Coral reefs, which once built worlds from limestone and light, can bleach to white within a single summer of heat. The scale is the same, but the speed is not. That is what makes this moment different. A mass extinction, by definition, is a sudden global loss of life. But what counts as sudden depends on who is watching. To a planet, 1,000 years is a blink. To us, it is forever. We are not used to feeling geological change in real time, yet here we are, watching the balance shift, slowly enough to ignore, but quickly enough to leave a mark that will be visible in stone. Scientists call this the collision of two clocks, the biological and the human. Evolution moves in the rhythm of ages, while our actions move in the rhythm of centuries, decades, even days. And when the faster clock interferes with the slower one, life cannot adjust in time. Every ecosystem on Earth is a web of timing, migrations, breeding seasons, chemical cycles, and ancient instincts tuned to the turning of the planet. A single degree of change can move the seasons out of sync. Flowers bloom before pollinators arrive. Ice melts before birds return north. The harmony breaks, not with a crash, but with a soft unraveling. That unraveling is what scientists measure now, not just in fossils, but in living records, satellite maps, and the genomes of creatures still fighting to adapt. The data is clear, though the story it tells is quiet. Extinctions that once took millions of years are now occurring hundreds of times faster. If the planet is entering another of its great endings, this is how it begins, not with a single disaster, but with many small silences, accumulating like dust. And yet, within those silences, life still breathes. The pulse has not stopped, only quickened. The story is not over. It is still being written, one fragile page at a time. There was a time when the earth came closer to silence than it ever had before. It began quietly, as endings often do. A change in the air, a shift in the color of the seas, a faint tremor beneath the soil. Life, still abundant and unaware, carried on until the rhythm broke. It was the end of the Permian period, more than 250 million years ago. The continents were joined together in a single vast land called Pangaea. Forests of strange trees stretched across the interior. Reptiles, amphibians, and insects filled the swamps, while the oceans shimmered with coral reefs and creatures whose shapes no longer exist today. The world seemed full, even eternal. Then, far to the north, the earth opened its lungs and began to exhale. In what is now Siberia, the crust tore apart. Rivers of molten rock flooded across the land, not for days or years, but for hundreds of thousands of years without pause. The eruptions released more carbon dioxide than any volcanoes before or since. It was not a single explosion, but a relentless fire, a wound in the planet that would not close. At first, the change was slow. The air warmed by a few degrees. The oceans began to absorb carbon dioxide, turning slightly more acidic. Plants struggled under a sky that no longer felt the same, but soon the balance tipped. The seas grew hotter. The chemistry of the water shifted. Shells dissolved. Coral reefs collapsed. The oxygen that fish once breathed slipped away into nothingness. Scientists can still see this moment written in stone. Black bands of carbon mark where oxygen vanished from the ocean floor. Layers rich in sulfur tell of seas that turned poisonous, filled with the breath of microbes thriving in a world without air. The fossil record thins until, for a time, it almost disappears. By the end, 96% of marine life was gone. 70% of land species followed. Forests turned to ash and did not return for millions of years. The insects, once the unstoppable engineers of the land, nearly vanished altogether. This was the great dying, the closest the earth has ever come to losing everything. Imagine walking through that silence. No birds, no rustle of leaves, no color in the sea. The horizon itself would have felt empty, as if the world had forgotten how to breathe. It was not a single catastrophe, but a long unraveling. The air grew thick with greenhouse gases, the climate spiraled, rain turned acid, oceans boiled from within, and yet, even in that devastation, life found a way to wait. Deep within the soil, tiny creatures endured. In the darkest corners of the sea, a few species clung to the last threads of oxygen. Those survivors would become the seeds of everything that followed. It took 10 million years for the Earth to heal. That span of time is difficult to imagine, longer than the existence of humanity itself. In those ages, new forests took root, new animals appeared, and evolution began its slow rebuilding. But the scars of that era never truly faded. They remain, written in the chemistry of rocks, whispering of a planet that once burned itself sick. When scientists study the great dying today, they do not just see the past, they see a warning. The same symptoms that marked the end of the Permian are appearing again, one by one. The rise of greenhouse gases, the warming of oceans, the loss of oxygen in the deep sea, all familiar signs, returning in a new form. In the Permian world, the trigger was volcanic fire. In ours, it is something quieter, yet just as powerful, the collective breath of human industry, factories, engines, and fires, each releasing invisible gases that climb into the sky. The air thickens, slowly, imperceptibly, until the balance begins to shift once more. Of course, today's Earth looks alive. The forests are green, the oceans glimmer blue, but beneath that beauty, the same invisible processes stir. The chemistry of the seas is changing. Coral reefs are struggling to build their skeletons. Oxygen levels in the ocean depths are falling. The air holds more carbon now than at any time in human history. It is not that we are living the great dying again, but that we are echoing its opening notes. The same imbalance between air, ocean, and life that once pushed the planet to collapse is stirring once more. The difference is time. What took the volcanoes hundreds of thousands of years, we are accomplishing in hundreds. The rocks that recorded that ancient disaster speak of thresholds, moments when small changes became irreversible. No one in the Permian could have sensed the tipping point as it passed. The creatures simply lived, adapted, and then, without warning, vanished. When we look back on that age, we are not staring into an alien world. We are looking into a mirror, seeing the reflection of Earth in crisis and recovery. The lesson it leaves behind is not one of despair, but of scale. The planet will endure, it always has, but the forms of life that fill it are fragile, as fleeting as breath. In the end, the great dying was both an ending and a beginning. The earth nearly lost its song, but from the silence, a new melody slowly rose. Reptiles evolved into the first true dinosaurs. The oceans, though empty for ages, filled again with strange new swimmers. Life rebuilt itself, reshaping the planet all over again. It is humbling to know that our world has already faced such endings, and even more humbling to realize how easily the same story could begin again. The earth remembers. It has survived fire and poison, silence and ash, and in its memory lies a truth as quiet as it is vast, that every living thing, no matter how small, is part of that same fragile rhythm, and when that rhythm falters, the whole world listens. The earth has always kept its memories close. Even after millions of years, it still holds them, pressed in stone, sealed in layers of ash and clay. Each stratum tells a story of warmth and cold, of abundance and silence, of life that rose and vanished. Scientists have learned to read those pages, tracing the patterns of catastrophe and recovery that shaped our planet's long history. In the deepest rocks, they found the echoes of ancient deaths, the thin black lines that mark the great dying, the dusty bands that remember the fall of the dinosaurs, the traces of oceans that lost their breath. And between those layers, they discovered something unexpected, a rhythm, the same sequence of changes, repeating across different ages, like a song the planet forgets and then remembers again. Now, as researchers turn their instruments toward the present, they see those same signatures returning, not carved into rock this time, but unfolding in real time. The first sign is in the air. Carbon dioxide, the invisible gas that once turned the Permian world into a furnace, is climbing again. For hundreds of thousands of years, its levels rose and fell with the rhythm of ice ages. Then, in a heartbeat of geological time, it surged far beyond anything seen in the history of our species. The numbers on the instruments rise faster than models predicted. The line on the graph steepens. To most eyes, the sky still looks blue. The clouds still move as they always have. But the chemistry has shifted. Each breath we take now carries traces of an atmosphere that feels strangely familiar to the ancient earth. The second sign is beneath the waves. Coral reefs, the architects of entire ecosystems, are losing their color. What looks at first like beauty, reefs turned white as marble, is in truth a quiet kind of death. The corals are expelling the tiny algae that feed them, driven out by heat. Without those partners, the corals fade, starve, and crumble. Once vibrant underwater cities fall silent, their inhabitants scattering into the empty blue. Mass coral bleaching was once rare, separated by decades or centuries. Now it happens again and again, closer each time, like a fever that will not break. Scientists dive into the same reefs they studied as students and find them unrecognizable, the living replaced by bone. The last time the oceans lost their color, it marked the beginning of a collapse that took millions of years to heal. The third sign lies in the numbers of life itself. Across continents, wildlife populations are shrinking. Insects, birds, fish, mammals, all counted and recounted in quiet studies that reveal the same trend. Biodiversity, the measure of Earth's living variety, is dropping at a rate seen only during mass extinctions. It does not announce itself loudly. The forest still stands, the river still runs, the field still flowers. But look closer, and the songs have thinned. The webs of connection that hold ecosystems together are beginning to fray. The scientists who track these changes often speak of a strange unease. They have seen these patterns before in the rocks and the data of deep time. Rapid rises in carbon dioxide, sudden ocean acidification, collapsing food webs. Each one alone could be survivable. Together they form a chorus that is painfully familiar. Even the planet's surface is beginning to record this moment. Sediments in lakes and seabeds already contain the fingerprints of our age, layers rich with plastic fragments, chemical residues, and soot. Future geologists, if they exist, will one day find these marks and recognize them as we now recognize the traces of the past. They will see a sudden shift in composition, a line that divides one world from another. This idea has come to be known as the sixth extinction hypothesis. It is not a prophecy, but a question. Are we witnessing the start of another mass extinction, one not caused by ice or fire, but by a species capable of understanding what it is doing? The evidence is not absolute. Some scientists argue we have not yet crossed the threshold, that the losses, though terrible, remain reversible. Others look at the accelerating trends and say the threshold may already be behind us. The debate continues, but the data does not sleep. Satellites record shrinking forests and bleaching reefs. Instruments track the thinning oxygen in the sea. Drones follow the migration paths of animals that no longer arrive where the seasons once led them. Every signal, every graph, every piece of evidence forms a larger pattern, one that mirrors the earliest stages of the events that reshaped life before. To many researchers, this familiarity is haunting. They have studied the end of the Permian, the fall of the Cretaceous, the suffocation of the Devonian seas, and now they watch the same processes awaken again, this time under skies filled not with volcanic ash, but with the breath of our machines. The rocks remember, and their warnings sound familiar, but the earth is vast, and its rhythms are patient. The planet has endured before. It has burned and frozen and healed again. What makes this age different is not the danger itself, but the awareness of it. For the first time in the long history of life, one species can see the signs appearing, can measure the rise of carbon, can trace the bleaching of reefs, can name the silence spreading across the forests. In that awareness lies something fragile and rare, the ability to recognize the rhythm before it reaches its crescendo, the ability perhaps to change the pattern before it is carved into stone again. For now, the earth still turns beneath a blue sky. The seas still shimmer, though they are warming. The forests still breathe, though their lungs are thinning. The signs have returned, and the story is beginning to rhyme. The question, softly lingering in the air, is whether we will learn the melody before the silence takes its place. There was a moment in history when the rhythm of the earth began to quicken. It was not marked by fire or flood, nor by a sudden change in the color of the sky. It began quietly, with the hum of machines and the flicker of lamplight, when human hands learned how to turn coal and oil into power. From that moment onward, the planet entered a new tempo, one it had never known before. The Industrial Revolution began as a whisper of invention. Engines burned fuel, and the air filled with the breath of progress. Factories rose beside rivers, drawing energy from steam and water. Cities spread like constellations of light, and within a few generations, the world's population began to swell. What had once taken nature millions of years to form, the slow conversion of ancient sunlight into coal and oil, was being undone in mere centuries. By the middle of the 20th century, the rhythm grew frantic. Historians now call this period the Great Acceleration. In the years after 1950, nearly every curve on a scientific graph turned sharply upward. Population, energy use, industrial output, carbon emissions, the number of vehicles, the rate of deforestation. Each line, once gentle, began to climb like a wave rising toward its crest. For the first time, a single species had become a geological force. Humans began to move more rock, soil, and sediment than all rivers, glaciers, and winds combined. Mountains were carved for minerals, valleys reshaped for roads and cities. The Earth's crust, once molded only by tectonics and erosion, now bore the fingerprints of our machines. If a future geologist were to dig through these layers, they would find the unmistakable mark of human hands, a sudden stratum of concrete, plastic, metal, and bone. In a way, we became both the storytellers and the story itself. We are not just inhabitants of the planet anymore. We are shaping its next chapter, writing our own layer into the fossil record. The acceleration was not only physical but chemical. The carbon that had been locked underground for hundreds of millions of years began to re enter the atmosphere, molecule by molecule. The balance of gases that once kept the planet's climate stable began to tilt. Invisible as it rose, this new breath of the industrial world gathered in the air, trapping sunlight, warming oceans, softening ice. The changes it brought were too slow for a single lifetime to notice, yet far too fast for the planet to absorb. From above, the transformation of Earth looked almost alive. Satellites captured forests retreating like tides, coastlines glowing with electric veins, deserts expanding where rivers had once run. Plains traced white scars of vapor across the sky. Cities pulsed with heat, visible from orbit, spreading warmth into the night air. To those living within it, this change felt like progress. Life became faster, brighter, more connected. Machines shrank, information moved at the speed of light, and the boundaries of the natural world seemed to recede before human ambition. Yet beneath the glow of modern life, the Earth's systems were beginning to strain. Forests cleared for farmland released their stored carbon. Fertile soils eroded under the weight of crops. Rivers once wild were tamed by dams, their sediment trapped and their currents slowed. Every new invention carried both promise and cost, often unseen. Plastic, created as a symbol of convenience and modernity, now drifts in the oceans and settles in the deepest trenches. Metals drawn from the crust form the bones of our machines, but leave behind the open wounds of minds. The energy that built civilizations has left behind a thin, persistent haze that wraps the sky, and still the acceleration continues. The pace of change no longer feels like the steady beat of a drum, but the blur of a spinning wheel. Data travels faster than sound, markets move faster than weather, and species vanish faster than they can be cataloged. The earth beneath us is no longer a backdrop, but a participant in our story, responding to every choice we make. When scientists speak of the Anthropocene, the proposed age of humans, they are describing this very moment. It is an epoch not measured by rock formations or ice ages, but by the reach of our influence. The line that separates the natural from the human-made has grown faint, and the planet itself has entered a new state, shaped by our collective presence. Yet, even amid this acceleration, there is a strange stillness when viewed from space. The continents look the same, the oceans shimmer as they always have, and clouds drift in their endless cycles. But beneath that calm surface, the data reveals a world in motion, forests breathing less, glaciers retreating farther, coral reefs paling under the weight of warmth. The same invisible chemistry that once ended worlds is stirring again, not from volcanoes or asteroids, but from engines and fires we built with our own hands. What makes this era remarkable is not only the speed of change, but its scope. Every corner of the Earth, from the highest atmosphere to the deepest ocean, now carries traces of our existence. A grain of sand on a distant beach may hold plastic dust. A snowflake falling on a polar cap may contain soot from a city thousands of miles away. The planet has become a mirror, reflecting both our ingenuity and our excess. We have crossed into a time when the boundaries between humanity and nature have blurred completely. We are part of the same pulse that drives the tides and the wind, yet we have amplified it beyond its ancient rhythm. The age of acceleration is not just a chapter of progress or peril, it is a moment of recognition, the realization that we are no longer passengers on this planet, but its sculptors, its witnesses, and its future fossils. The Earth will remember us, not through words or monuments, but through the layers we leave behind. Each grain of ash, each shard of glass, each whisper of carbon will speak of an age when one species, for a brief and brilliant instant, became the force that changed the world. If the earth were to whisper its story today, the sound would not be one of explosions or storms. It would be a soft fading, the quiet subtraction of life from the edges of the world. Scientists have begun to count that fading, not through the loud signs of disaster, but through the slow arithmetic of loss. Since the year 1970, the total population of wildlife across the planet has fallen by nearly 70%. Forests still stand, rivers still flow, the surface of the world looks alive. Yet beneath that familiar skin, something essential is thinning, almost imperceptibly, like breath on a cold window. In the rainforests of South America, the frogs that once filled the nights with sound are disappearing. In fields across Asia and Europe, insects that pollinated crops and flowers are vanishing from the air. Along the coasts, coral reefs, once radiant cities of color, are turning pale, their structures crumbling as the warmth and acid of the sea unravel their skeletons. Each loss seems small on its own. Together, they form a silence that spreads across continents. Extinction is not always sudden. It rarely comes with a single moment of death. Often, it arrives quietly, disguised as survival. A species may still exist, but its role within its world is gone. Biologists call this ecological death, when a living species can no longer do what it once did to keep the balance of its environment. A reef fish might still swim, but in numbers too small to clean the corals. Bees might still buzz, but not enough to pollinate the fields that once depended on them. Trees might still rise on a mountainside, but without the birds and insects that spread their seeds, they become stranded generations of green. Life continues, but the web that once connected it begins to unravel. To understand this loss, imagine an orchestra where each instrument represents a species. The violins fade first, their sound thinning until it can barely be heard. The drums slow, the flutes fall silent. The music still plays, but it no longer carries its shape or harmony. Eventually, the melody is gone, though the stage is not yet empty. That is ecological death, a song that still exists in name, but no longer in sound. Across the planet, scientists are trying to measure this vanishing in real time. In the mountains of Costa Rica, long-term surveys show the disappearance of amphibians that once thrived in the misty forest streams. Many were driven not by hunting or habitat loss, but by a microscopic fungus that spread with the warming climate, thinning their fragile skin. In Europe, entomologists have been counting insects caught in traps over the decades. Where there were once hundreds of thousands, there are now only fragments of that number. The air itself has become quieter, not just to the ear but to the senses of other animals, birds that hunt by sight, bats that feed by sound. The absence ripples outward, reshaping ecosystems that evolved in tune with the hum of pods, countless wings. And in the oceans, the decline is just as deep. Coral bleaching is only the beginning. The collapse of reefs erases habitats that feed a quarter of all marine species. When those corals die, fish lose their homes, predators lose their prey, and the ocean begins to lose its balance. The sea still looks vast and blue, but beneath the surface, its complexity is draining away. Even on land, the losses build invisibly. Soil, alive with fungi, roots, and insects, becomes sterile when its small inhabitants vanish. Forests that appear lush may no longer exchange nutrients in the way they once did. The connections that sustain life are delicate, and when one breaks, others follow, sometimes centuries later. What makes this moment different is how clearly we can measure it. Satellites now record the greenness of the earth, tracking how forests breathe through the seasons. Underwater microphones capture the fading of natural soundscapes, the drop in whale songs, the silence of once busy coral reefs. Artificial intelligence sorts through millions of images, counting the creatures that remain. Every new tool, every dataset, confirms the same quiet trend, a world that is slowly dimming. And yet, to most of us, that dimming is invisible. We still see birds in the sky, hear insects at dusk, watch fish flash in the shallows. It feels as though life endures, unchanged, but the numbers tell another story. The abundance that once filled the world has fallen to a fraction of what it was. What remains is thinner, quieter, a pale echo of its former self. The sixth extinction does not begin when the last creature dies. It begins when the world stops noticing, when silence becomes ordinary, when a vanished bird is not missed because no one remembers its song, when a forest still looks green, even though its roots have stopped speaking to one another. It is difficult to see absence, harder still to measure it. Yet scientists continue to count, not out of despair, but out of reverence, a way of bearing witness to a living planet that is changing before our eyes. In their records, in their patient observations, there is a kind of quiet devotion, a belief that even the faintest traces of life are worth knowing before they are gone. And so, the measurements continue in the air, the soil, and the sea. The data forms a portrait of a planet still breathing, but more shallowly now, as if remembering how it once was. Life, after all, does not disappear all at once. It drifts away, one unnoticed heartbeat at a time. The ocean has always seemed eternal, its vastness, its unbroken blue, its pulse that has never ceased since the dawn of the planet. From the shore, it still looks the same. Waves rise and fall, sunlight glints over the surface, and the scent of salt drifts through the air. Yet beneath that calm reflection lies a quiet unraveling. The sea is changing, and it is doing so faster than at any other time in its ancient memory. For most of Earth's history, the ocean has been the keeper of balance. It absorbs the heat of the sun, carries storms across continents, and cradles nearly 3/4 of all life on the planet. Every breath of air, every drop of rain, every change of season depends on its slow, steady circulation. But now, the same waters that once gave stability are absorbing more than they can bear. The ocean has always taken in carbon dioxide, drawing it from the air and locking it away in its depths. This exchange kept the atmosphere livable for millions of years. Today, that partnership is being tested. The seas are taking in carbon faster than at any known point in history. With each passing year, more of it dissolves into the water, turning it slightly more acidic. To the human eye, the ocean looks unchanged, but to the creatures that build their homes from calcium and light, it feels different. Their shells dissolve more easily. Their corals cannot grow as strong. The chemistry of survival is shifting beneath the surface. At the same time, the ocean is warming. The excess heat trapped by greenhouse gases does not remain in the air. Over 90% of it is absorbed by the sea. The surface grows warmer, and the heat seeps downward, disturbing the currents that have guided life for eons. Cold, nutrient-rich waters no longer rise as they once did. Plankton blooms falter. Fish migrate to cooler regions, leaving empty waters behind. The sea's invisible architecture, its flows, layers, and temperatures, is being rearranged. To a diver descending into such waters, the change is not immediately seen but felt. The corals appear pale, their colors drained like faded paint. The water feels thicker, heavier, quieter. The familiar bustle of reef life, the darting of small fish, the hum of shrimp, the glitter of scales in sunlight, has dimmed. Where there was once a riot of movement, there is now an eerie stillness. Overfishing has carved its own silence into the sea. For centuries, the ocean seemed infinite, an inexhaustible pantry. But technology turned fishing into industry, and industry turned the ocean into a field harvested without pause. Nets now sweep through depths once untouched, gathering everything in their path, not just the fish sought, but turtles, sharks, dolphins, and countless unseen lives. In some parts of the world, the weight of the catch has fallen by more than half since the mid-20th century. Many species once common enough to feed nations are now ghosts in their own waters. The loss is not uniform. It spreads in uneven patterns, like bruises beneath clear skin. Coastal waters, where coral reefs once thrived, are fading first. Coral is not merely a creature but a foundation, a living architecture that shelters thousands of species. When the reefs die, the ecosystem collapses with them. Fish lose their breeding grounds, predators lose their hunting grounds. The web of life frays from the edges inward until the sea, still blue from above, begins to lose its true color. Scientists now find plastic drifting in every current and every depth, from the surface foam to the deepest trenches. The fragments are small, sometimes invisible, but they are everywhere. In the bellies of whales, in the bodies of seabirds, in the plankton that form the base of the food chain. In some waters, plastic particles now outnumber the plankton themselves. They move through the ocean's veins, bright and lifeless, a new kind of sediment that future geologists will one day uncover and call ours. Even the sound of the ocean is changing. The songs of whales, once carried clearly through vast distances, are muffled by the noise of ships and machines. The deep groan of engines now echoes where silence used to reign. The ocean's heartbeat, once shaped by wind and tide, has taken on the rhythm of human activity. And yet, to stand on the shore is to see none of this. The horizon remains wide and blue, the waves still roll as they always have. But that color, that brilliant, endless blue, is not what it used to be. Beneath it, the ocean's living light is fading. The pigments that came from coral, from fish, from the microscopic plankton that scatters sunlight into color, are vanishing. The blue remains, but the life that gave it depth is slipping away. It is a strange kind of loss, one that hides behind beauty. The sea still glitters in the morning sun. It still carries ships and reflects the sky. But within its silence lies the weight of everything it has absorbed, our heat, our waste, our hunger. The ocean has always been generous. It gives rain, food, air, and rhythm to the world. Now it is giving something else, a warning written in temperature and chemistry, in empty reefs and hollow sounds. The sea still looks blue, but beneath it is losing its color, not all at once, but gradually, like ink fading from a once bright page. And though the surface continues to sparkle, the stories written below it grow fainter with each passing tide. The ocean remembers every warmth, every change, every silence. It remembers the world as it was, and deep within its unseen depths, it holds the memory of what it means to be alive. From space, the Earth looks alive. Clouds drift like breath across green continents, and the great forests stretch like veins across the skin of the planet. For most of history, these forests were the lungs of the world. They took in the carbon that life exhaled and returned clean air to the sky. Each leaf was a living filter, each tree a small engine of balance. Together, they formed a system so vast and ancient that the planet itself seemed to inhale and exhale through them. Now, that rhythm is faltering. The Amazon rainforest, often called the heart of the world's green network, once absorbed billions of tons of carbon dioxide every year. Its trees pulled the gas from the air and stored it within their trunks, branches, and roots. Rain fell, leaves decayed, and the cycle continued, a breath that nourished all life. But that balance is beginning to shift. The forest that once breathed for Earth is starting to exhale smoke. In parts of the Amazon, the pattern has reversed. Deforestation and fire have grown so intense that some regions now release more carbon than they capture. What was once a sponge has become a source. The transformation is quiet but monumental. A living system that spent millions of years cooling the planet is now warming it. The causes stretch far beyond the forest's edge. Roads carved deep into the green, opening paths for logging, farming, and mining. Trees felled by chainsaws lie in rows like fallen soldiers, their stumps bleeding sap into the soil. Fires, both deliberate and accidental, spread through the dry underbrush, filling the air with a haze that stretches for thousands of miles. Each blaze adds carbon to the atmosphere and strips away the forest's ability to recover. In the Amazon's dry season, the horizon glows orange at night. The smoke climbs into the air and drifts over cities, rivers, and mountains. To the people who live there, the smell of burning wood has become a season of its own. What was once a forest of endless green now holds scars visible from the sky. But the Amazon is only one part of a larger story. Across the planet, forests are retreating. In Southeast Asia, tropical forests give way to palm plantations that feed global markets. In Africa, wood is gathered for fuel, stripping hillsides bare. Even the great boreal forests of the north, stretching across Canada and Siberia, are changing as the climate warms. Fires that once occurred once in a century now return every decade. Insect infestations, once limited by cold winters, now spread freely, leaving miles of dead trees standing like a forest of ghosts. Each loss weakens the Earth's ability to balance itself. Trees are not just scenery, they regulate temperature, store water, create clouds, and anchor soil. Their roots hold rivers in place, and their leaves release moisture that becomes rain hundreds of miles away. When the forest thins, rainfall patterns change. Droughts deepen, rivers shrink. What begins as deforestation becomes a shift in weather itself, a slow unraveling of the planet's circulation. In the Amazon, scientists are beginning to notice that rainfall is no longer as predictable as it once was. The great rivers still flow, but the dry seasons linger longer. Areas that were once too wet to burn now catch fire with ease. The forest feeds on its own moisture, creating its own weather. But if enough of it disappears, that self-sustaining cycle could collapse. The rainforest could transform into a dry savanna, a change so vast it would alter the entire climate of the hemisphere. For now, the forest still breathes, but unevenly. Some regions continue to take in carbon, while others exhale it back into the sky. The balance teeters. What was once a chorus of green respiration is now a strained harmony, punctuated by the crackle of fire. When scientists measure the air above the Amazon, they can detect the shift. Instead of absorbing carbon dioxide, parts of the forest now emit it. The data tells a story of exhaustion, a living system pushed beyond its limits. It is not the death of the forest, not yet, but it is the sigh of one struggling to keep up. And yet, within the chaos, there is resilience. After a fire passes, new shoots rise from the ashes. Seeds hidden in the soil sprout with the first rain. Animals return, cautious but determined. The forest remembers how to heal, but healing takes time, and time is what the world is taking away. The trees that once cooled the air now stand amid a heat they cannot escape. The rain they once summoned now comes less often. The soil, once rich with life, hardens under the sun. It is as if the earth's lungs are still breathing, but more shallowly, struggling to draw in enough air. Across the planet, forests beyond the tropics echo the same pattern. The Siberian taiga smolders under record heat. The pine forests of North America, once green and dense, are streaked with gray where drought and fire have passed. Even the small pockets of woodland that survive in cities are feeling the change, trees shedding their leaves too early, blossoms opening before the pollinators arrive. From above, the planet still wears its green skin, though thinner now, patchier. But if you listen closely, you can hear the change in rhythm. The soft inhale of the world is becoming shorter. The exhale, longer and heavier. The forest that once breathed for Earth is starting to exhale smoke. And in that haze, the memory of a living, balanced world drifts upward, waiting for the wind to carry it somewhere it can begin again. They are small enough to go unnoticed, yet they hold the weight of the world in their wings. For hundreds of millions of years, insects have been the quiet engineers of life on Earth. They outlasted dinosaurs, survived ice ages, and adapted to every climate and corner of the planet. From rainforests to deserts, from high mountain air to deep under the soil, they filled the spaces between things, the unseen workers of an ancient rhythm. It is said that if all humans vanished tomorrow, the planet would heal. But if insects disappeared, the world would fall apart. Insects make up nearly 80% of all animal species. They pollinate flowers, recycle decay, and form the foundation of countless food webs. Every grain of soil, every leaf, every drop of nectar has known their touch. They are the translators between life and death, the carriers of pollen, and the keepers of renewal. And yet, the age of insects, one of the most enduring eras in the planet's story, is beginning to falter. Across meadows that once shimmered with butterflies, the air is quieter now. In cities, porch lights attract fewer moths than they once did. In farmlands, honeybees that once danced between blossoms are vanishing from their hives. The decline is steady, widespread, and deeply strange. Scientists have measured it in numbers that seem almost impossible to imagine. In parts of Europe, more than 3/4 of flying insects have vanished within a single human lifetime. The decline is not limited to one place or one kind. Beetles, ants, bees, and dragonflies are all fading together. In tropical forests, where insect life once filled every shadow, researchers now speak of an emptiness that cannot be explained by seasons or chance. To understand what this means, it helps to imagine how deeply life depends on them. A single honeybee may visit thousands of flowers in one day, carrying grains of pollen that will become fruit, seeds, and forests. Without that exchange, plants cannot reproduce, crops would fail, wildflowers would disappear, and the animals that depend on them, birds, mammals, even fish that feed on fallen seeds, would follow. But pollination is only part of the story. Beneath our feet, insects break down leaves, wood, and waste, turning death back into soil. Without them, the earth would fill with decay. Nutrients would remain locked away, unreachable for new life. The balance that has held for eons would stop, and the planet's cycles of renewal would slow to stillness. Insects are also food, not just for one species, but for thousands. Bats hunt them in the night skies. Birds gather them to feed their young. Frogs, reptiles, and small mammals depend on them as their primary meal. Remove the insects, and the hunger ripples upward through every ecosystem. Scientists call this the trophic cascade, but it feels more like the dimming of a great orchestra. When the smallest disappear, everything larger begins to follow. The reasons for this decline are as complex as the insects themselves. Pesticides coat the fields, meant to protect crops, but they seep into the very fabric of the landscape. The air, the soil, the water, all hold traces of chemicals that confuse or kill even those creatures they were not meant for. Light pollution disorients nocturnal insects, drawing them from the safety of darkness into deadly circles of brightness. Habitat loss removes the flowers, trees, and wild spaces where they once thrived. And the warming of the planet, subtle yet relentless, shifts the timing of seasons. Flowers bloom too early or too late. Rains come at the wrong time. The synchrony between insect and environment begins to unravel. There is no single event, no great catastrophe, just countless small absences adding up. One meadow with fewer bees, one stream with fewer mayflies, one forest where the air feels stiller than it used to. The losses are so quiet that many people barely notice them until they look back and realize how different the world has become. Entomologists, the scientists who study insects, often speak with a kind of reverence when describing their work. They spend hours crouched in the grass or bent over soil samples, watching the smallest lives at work. For them, the decline is not just data on a chart, it is the vanishing of a familiar hum, the disappearance of movement that once filled the world's background. In some regions, conservation efforts are trying to slow the loss. Fields are being replanted with wildflowers, pesticide use is being reduced, corridors of natural habitat are being reconnected so that insects can move freely between them. Yet even with these efforts, the recovery is uncertain. Insects are ancient and adaptable, but the speed of modern change is something their evolution has never faced before. What makes their story so haunting is that it unfolds beneath our awareness. Insects do not roar or sing. They do not leave behind the kind of fossils that record their presence in stone. Their extinction is a fading of texture, of movement, of sound, a disappearance written in the silence between seasons. When the age of dinosaurs ended, it left a crater. When the age of insects ends, it will leave a quiet so deep that it might take centuries to understand what was lost. Even now, as fields still shimmer with the wings of dragonflies and the hum of bees still lingers in summer air, the rhythm feels different. The pulse that once connected flower to pollinator, soil to seed, has slowed. The world, for all its noise and color, depends on lives too small to see clearly. And as those lives flicker out, one by one, the great fabric of nature loosens. The earth still breathes, but its breath feels thinner, as if it, too, is waiting for the return of the hum that once filled its every corner. When the smallest disappear, everything larger begins to follow, and the sound that leaves behind is not a crash, but a silence so vast it can only to be heard when you listen for what is no longer there. At dawn, the world once began with music. Before the first rays of sunlight touched the land, the air would fill with sound, a chorus of calls and songs layered like an invisible symphony. Every tree, every reed, every stretch of coastline joined in. It was the language of wings and wind, the sound of life announcing itself to the day. Now, in many places, that morning concert grows quieter. The rhythm of wings still rises with the sun, but the voices have thinned. It is not silence yet, only the slow fading of it, a dimming of the sky's melody that most do not notice until they remember what used to be there. Birds have always been the planet's most visible travelers, linking continents through the air. They carry seeds, spread life, and connect ecosystems across oceans and mountains. In their flight, they reveal the health of the earth itself. Where they thrive, the world thrives. Where they vanish, something beneath the surface is changing. Scientists have long thought of birds as messengers, warning us of shifts too vast or too quiet to see directly. In the 20th century, canaries were carried into coal mines to detect invisible toxins. Today, the birds themselves are warning us again, not from beneath the ground, but from the open air. Since the 1970s, North America alone has lost nearly 3 billion birds. The number feels almost too large to imagine. It means that for every 4 birds that once filled the skies, one is now gone. The forests, fields, and wetlands still stand, but they no longer echo in the same way. The skies look no emptier to the eye, yet their sound has changed. The losses reach across every kind of habitat. Meadowlarks no longer brighten the prairies in the same numbers. Swallows that once skimmed the evening air above rivers are harder to find. Even the small sparrows and finches that filled backyards and gardens are fading. Some migratory birds have seen their populations drop by more than half within a single lifetime. There is no single cause, but rather a web of quiet pressures unraveling at once. Climate change shifts the seasons, altering when insects hatch, when flowers bloom, and when fruit ripens. Birds that migrate thousands of miles rely on timing so precise that even a few days' difference can mean the loss of food along the way. A journey that once carried them from abundance to abundance now leads to empty skies and barren branches. Light pollution has changed the very shape of the night. Where once the stars guided their flight, the glare of cities now blinds and confuses them. Millions die each year colliding with glass towers that mirror the moonlight. Others circle endlessly under artificial skies until exhaustion brings them down. To a migrating bird, a city at night is not a beacon of safety but a labyrinth of false horizons. Habitat loss has stripped away the resting places between journeys. Wetlands drained for farms, forests cleared for roads, fields paved over for growing towns. Each fragment removed from the map erases a place where birds once paused, fed, and gathered strength. The skies are wide, but without safe ground below, even flight cannot save them. And beneath all of this lies the thinning of food itself. Insects, the quiet foundation of every ecosystem, have dwindled, leaving fewer meals for the swallows, warblers, and flycatchers that depend on them. A bird can cross oceans and survive storms, but it cannot live where the air is empty of life. The consequences ripple outward. When birds disappear, the world beneath them begins to change. Seeds go ungathered, pests go unchecked, forests grow differently when their gardeners are gone. What seems like the loss of song is, in truth, the loss of an entire language between the living things of the earth. Still, there are moments of grace. Some species adapt, shifting their migrations northward, learning to nest in new climates. Others thrive in unexpected places. City pigeons and crows, resilient and clever, living among humans as if to remind us that survival is also a kind of evolution. But for every bird that endures, many more vanish without notice, their songs leaving behind only an absence that feels both vast and delicate. To scientists who study these changes, the data speaks in numbers, but to anyone who listens at dawn, the truth is simpler. The mornings are quieter, the spaces between each note are wider, the breeze carries less music than it once did. Each missing song is a measure of the silence spreading. It is not the silence of peace, but of absence, the slow fading of a dialogue that has lasted since the first creatures took to the air. The earth has always sung through its birds, each voice part of a greater harmony. That harmony is still here, still beautiful, but thinner now, like the last echoes of a melody drifting away on the wind. Some mornings, the chorus still rises strong, a memory of what the world can sound like when it is whole. In those moments, the air feels alive again, the way it did for millions of years before we began to change it. But even then, if you listen closely, there is a softness in the space between notes, a reminder that not all who should be singing are still here. The sky remains vast, the flight paths endless, but the voices that once carried across them are growing fewer, and in the hush that follows, the planet seems to listen to itself, waiting to remember the sound of its own song. For millions of years, the great animals of Earth have carried the memory of deep time within their bones. Their shapes are ancient, their presence a living link to the world that once was. Elephants, whales, rhinos, creatures so large and enduring that they seem to exist beyond the reach of change. Their footsteps shook the ground, their shadows stretched across continents, their songs traveled through oceans. They were, in every sense, the elders of life, but even the giants are beginning to fade. Their numbers have thinned slowly, almost imperceptibly, like the receding tide, one generation fewer, one migration shorter, one herd quieter than before. Extinction isn't always sudden, sometimes it is a long goodbye. The story of these giants is not just about loss. It is about imbalance, the quiet unraveling that begins when the largest lives can no longer hold their place in the great web of life. Every ecosystem depends on such creatures, for they shape the world around them in ways both subtle and immense. When they vanish, the pattern beneath them changes too. On land, the elephants once served as gardeners of the wild. Their heavy feet cracked hard soil, letting rain seep into the ground. Their tusks tore through trees, clearing space for new growth. Their dung scattered seeds across great distances, planting entire forests in their wake. Through their slow migrations, they sculpted the landscape as surely as rivers shape valleys. Now, their paths are growing shorter. The wide corridors they once roamed have been divided by roads, farms, and cities. Families of elephants that once traveled hundreds of miles now live in pockets of isolation. Some have turned to wandering through villages in search of food, colliding with the world that replaced their own. Poaching for ivory has never fully ended. Even as awareness grows, the trade still flickers in the shadows, taking one life at a time, one tusk at a time. To see an elephant is to witness time itself, moving, but fewer and fewer people ever will. Across the oceans, the story unfolds differently, yet it carries the same quiet ache. The whales, the true titans of the sea, have sung across generations longer than human memory. Their calls, low and resonant, can travel for hundreds of miles through the deep. They once filled the oceans with their presence. Blue whales, humpbacks, right whales, fin whales, each species a different note in the vast song of the sea. Their decline began with harpoons. For centuries, they were hunted for oil, for meat, for bone. The whaling fleets of the 19th and 20th centuries left oceans haunted and empty. Some populations fell so low that only a few dozen individuals remained. The industry has largely ended now, but its echo lingers. The whales live on in smaller numbers, carrying scars of propellers and nets, navigating waters filled with the noise of ships that drown out their ancient songs. Even in the depths, they are not free from us. Pollution seeps into their world. Microplastics fill the stomachs of the smallest creatures, and through the food chain, they reach the largest. The ocean's warming currents shift their feeding grounds, scattering the krill and fish they depend on. Some species have begun to change their migrations, arriving too early or too late, their timing misaligned with the rhythms that once guided them. On land and sea alike, the giants are thinning, not through a single disaster, but through a steady accumulation of pressures. For rhinos, it is the endless pursuit of their horns. For elephants, the shrinking of their wild space. For whales, the transformation of the oceans themselves. Their disappearance is not only the loss of beauty or power, it is the quiet breaking of balance. The giants keep ecosystems stable in ways we are only beginning to understand. When whales dive and feed, they stir nutrients from the depths, fertilizing the surface waters where plankton grow. Those plankton, in turn, draw carbon from the air, helping to cool the planet. When elephants fall, forests lose their greatest gardeners. When rhinos vanish, grasslands thicken and dry, changing the way water moves through the earth. These are not just animals, they are forces of nature. In their decline, we can feel the world tilting toward stillness. The empty plains of Africa, where elephants once walked, the quiet bays where whales no longer breach, the dry savannas where rhinos once left trails in the dust. These are not absences alone, they are pauses in the living rhythm of the planet. Yet even as their numbers fall, there remains a deep resilience within them. Elephants still teach their young the paths to hidden water. Whales still sing to one another across the oceans. Rhinos still guard their calves under the heat of the sun. Life does not surrender easily, even when pressed to the edge. To witness the fading of giants is to glimpse the fragility of strength. It is to understand that even the mightiest creatures are bound to the same delicate balance that sustains all life. The age of giants has not yet ended completely, but it is quieter now. The thunder of hooves and the chorus of whale song have softened, replaced by the distant hum of machines. And in that softening, the earth seems to listen, to the spaces where the giants once moved freely, to the echoes of a strength that shaped the planet itself. The world still waits for their return, for the weight of their presence to settle once more upon its soil and sea. Until then, their fading remains a reminder of how vast life once was, and how even the grandest stories can end not with a crash, but with a whisper that drifts slowly into silence. The earth has always breathed in cycles of warmth and cold. Across its long history, the planet has frozen and thawed many times, reshaping itself with each turn of its slow rhythm. But the warmth rising now is different. It is not part of the old pulse, not the work of volcanoes or shifting continents. It is faster, sharper, and more complete. It touches every corner of the world at once, and with each fraction of a degree, the balance of life begins to tilt. Climate does not destroy in a single blow. It changes the conditions that life depends upon, rearranging the rules that have guided existence for millions of years. It does not kill directly. It unravels everything that depends on stability. The air has warmed by little more than 1 degree since the dawn of the industrial age, yet that small number carries a vast consequence. It is enough to melt ice that has lasted since the last glacial age, to shift the path of winds that drive the seasons, to warm the seas that cradle the weather of the world. Each ecosystem, each species, has evolved within a narrow band of temperature and light. When that line moves, even slightly, The map of life begins to blur. In the oceans, corals are the first to feel the fever. They are tiny animals that build vast cities of stone, working together with algae that live inside their tissues. The algae feed them with the energy of sunlight, and in return, the coral shelters them. When the water grows too warm, the partnership collapses. The algae flee, leaving the coral bare and white. The sea still glimmers above them, but beneath, the living color fades. This is coral bleaching, a quiet suffocation that spreads across the tropics, turning reefs that once roared with life into ghostly monuments of what they were. On land, the warmth creeps in ways less visible but just as deep. Forests that once thrived under cool canopies begin to shift their borders uphill and northward. Trees that cannot migrate fast enough wither in place. Animals that depend on them find themselves stranded in habitats that no longer match the climate they were born for. In the Arctic, the tundra thaws, releasing the smell of ancient soil that has been frozen for tens of thousands of years. The permafrost, once solid as stone, is melting. Within it lie the remains of plants and animals from vanished ages, all now decomposing as if the past itself were exhaling. As they decay, they release methane, a gas many times more potent than carbon dioxide. The thaw feeds the heat, and the heat feeds the thaw. This is what scientists call a feedback loop. It is nature responding to imbalance by amplifying it. When forests burn, they release the carbon they have stored for centuries, turning what once cooled the planet into something that warms it further. When ice melts, it exposes darker ground and water beneath, surfaces that absorb sunlight instead of reflecting it. The planet, once cooled by its own brightness, now darkens, warming itself faster. The effects ripple outward like a slow tide. Drought grips regions that once grew lush and fertile. Storms gather strength from warmer seas, carrying rain that falls too hard or not at all. Entire biomes, those great belts of life shaped by climate, begin to drift. Grasslands edge into deserts. Alpine meadows shrink beneath advancing trees. Even the jet stream, the ribbon of air that steers weather across the northern hemisphere, begins to wobble like a slowed spinning top, sending heat waves into places unprepared for them. What makes this warming so powerful is not only its scale but its speed. Life has always adapted to change, but not to change this fast. Evolution needs time. Ecosystems need generations to shift. The warmth we feel now is rising within decades, the blink of an eye in geological time. For creatures that depend on long rhythms of migration, flowering, or hibernation, the timing breaks. Birds arrive before insects hatch. Flowers bloom before pollinators emerge. Snow melts before rivers are ready to receive it. The harmony between species fractures, not with noise, but with absence. In the far north, ice that once sealed the seas through winter now vanishes before spring arrives. Polar bears, seals, and walruses lose the platforms they hunt from. Beneath the thinning ice, algae that once grew in the filtered light disappear, taking with them the food web that sustains the Arctic Ocean. And in that loss lies another paradox. The more the ice melts, the more the ocean absorbs heat, the less likely the ice is ever to return. The same pattern repeats across continents and seas. One change triggers another, and each feedback loop strengthens the next. It is as if the planet, long held in balance, has begun to tilt forward, slowly, yet with gathering momentum. Still, the earth remains beautiful. The skies are blue, the forests green, the seas alive with movement. To the eye, the world appears unchanged, but beneath the surface, in the chemistry of the air and the temperature of the deep, the threads that hold life together are loosening. Climate is not an enemy. It is the fabric that connects everything, the rhythm of wind and water that makes life possible. When that rhythm changes, everything else begins to move with it. The coral, the forest, the frost, even the air we breathe. And so the story of climate is not one of fire or flood, but of connection, of how warmth gathers in the smallest molecules and spreads outward until it touches every living thing. The earth has endured warmth before, and it will again. But for now, in this brief human chapter, the heat is still rising, and with it, the balance of all that breathes trembles, not in a sudden collapse, but in the slow, steady unraveling of the world's most ancient harmony. The ocean has always been the planet's great peacemaker. For billions of years, it has absorbed the excess, softened the extremes, and steadied the rhythm of Earth's changing air. It took the heat of the sun, the chill of the poles, and the breath of the world's creatures, blending them into balance. But that balance, like so many others, is beginning to shift. Every wave that breaks against the shore carries a quiet secret of chemistry. When carbon dioxide rises in the atmosphere, the ocean pulls much of it in, as if taking a deep breath on behalf of the planet. The gas dissolves into the water and forms a weak acid. Normally, the ocean can buffer these changes, a vast system of equilibrium that has kept life stable through countless ages. But there is a limit, and that limit is now being tested. In just a few human generations, the ocean's chemistry has changed faster than at any time in the past many millions of years. The water is becoming more acidic, molecule by molecule. The shift is small to the touch, invisible to the eye, yet its effects ripple through the foundation of marine life. The shells of tiny plankton, the exoskeletons of crustaceans, and the coral skeletons that build entire reefs are all formed from calcium carbonate, a mineral that weakens when the water around it turns even slightly acidic. Imagine trying to build a home from sand while the tide keeps rising. That is what life in the sea is now facing. The creatures that once built effortlessly now struggle to keep up with the pace of change. Coral reefs, already weakened by heat, find their skeletons dissolving faster than they can repair them. Shellfish larvae, so delicate that they are no larger than dust, fail to form proper shells before they even reach adulthood. In some coastal waters, oyster farmers have watched entire hatcheries collapse because the water itself has turned too corrosive for young shells to survive. Even the smallest forms of life, the plankton that drift through sunlit shallows, feel the change. These tiny architects, unseen but vital, are responsible for much of the oxygen we breathe. They are also the base of the marine food chain, feeding fish, whales, and everything in between. When their shells weaken, their numbers fall, and the web of life above them begins to tremble. The ocean still looks blue, still moves with the same grace, but its heart is changing. Scientists call this process ocean acidification, yet the phrase feels too clinical for what it describes. It is not just chemistry, but the quiet unraveling of stability itself. The sea that once cradled the beginnings of life is now struggling to support it in the same way. In the deep past, the earth has faced this before. The rocks remember, long ago, during times of intense volcanic activity, enormous amounts of carbon filled the atmosphere, warming the planet and changing the seas. The result was the same pattern we now begin to see again: oceans turning sour, shells thinning, coral dying, and life collapsing in waves that swept through entire ages. Those ancient events are recorded in thin layers of stone, where the fossils fade suddenly, replaced by silence. It is strange to think that we are now living through a version of that same story, one written not by volcanoes, but by the machinery of our own invention. Cars, factories, power plants, each a small vent of carbon, together creating a new kind of eruption that stretches across the sky. The ocean, ever patient, has absorbed nearly a third of what we have released, but its patience has a cost. In saving the air, it is losing itself. Near the poles, the effects are clearest. Cold water holds more gas, and so it becomes acidic faster. In the Arctic, pteropods, small, glassy snails known as sea butterflies, are found with their shells etched and pitted, dissolving as they drift. In the Southern Ocean, the same pattern appears. Tiny organisms that once floated unharmed now carry the marks of corrosion. The smallest shifts, magnified across entire ecosystems, are changing the shape of the sea. The consequences move upward through the chain of life. Fish that rely on sound to navigate find that noise travels differently in acidified water. Coral reefs that once protected coastlines from storms grow weaker and flatter, leaving shores exposed. Even the color of the ocean changes slightly as plankton populations shift. What looks like an untouched horizon hides a chemistry rewritten. The ocean has always been the great mirror of the atmosphere. When the air changes, the sea follows. For millions of years, that partnership has been one of balance, a slow conversation between sky and water. But now, the dialogue has quickened. The sea is absorbing carbon faster than it can release it, and with each new wave, its composition drifts further from the one that nurtured the first forms of life. Still, the ocean endures. It holds its vastness, its currents, its quiet authority. It is not dying, but transforming, adapting in ways both wondrous and perilous. New species may find their place in this altered chemistry, but countless others will fade into memory. The change is not loud or sudden. It happens in whispers, in the slow dissolution of shells, in the faint shift of pH, in the silence where once there was the crackle of reef life. If one were to listen carefully, perhaps the ocean itself would sound a little different now, its size longer, its rhythm slower, its balance uncertain. The sea has always been the keeper of the earth's breath, but as it takes in more than it can bear, that breath grows shallow. The ocean still holds life, still gleams under sunlight, still looks infinite, yet within that blue immensity, the chemistry that once gave rise to everything we know is quietly being rewritten, one invisible molecule at a time. The ground beneath our feet has always been alive. Long before cities, before fields of crops, before even forests rose to the sky, the soil was already a breathing world of its own. It held a quiet community of roots, fungi, and unseen organisms, an ancient collaboration that transformed stone to sustenance. Every grain of earth was part of a living fabric, woven from decay and renewal, life and death. For most of history, that balance held. The soil gave, and life returned the favor. Fallen leaves fed the roots of new trees. Rain filtered through layers of organic matter that purified it. Tiny microbes, invisible yet innumerable, broke down everything that fell upon them and rebuilt it into nourishment. The world's fertility was a slow, endless conversation between living and non-living things. Then came the chemical age. In the 19th century, humans learned to change the soil with science. We discovered how to capture nitrogen from the air and fuse it into fertilizer, feeding crops on a scale nature alone could not sustain. It was a breakthrough that transformed civilization. Fields flourished, yields multiplied, famine receded, the Earth's surface turned greener than ever before, and humanity's population surged alongside it. But abundance carries its own cost. We have turned abundance into a toxin. The very chemicals that once promised renewal have begun to smother the life they were meant to nourish. The soil, once an orchestra of living processes, is now growing silent in many places. Fertilizers, when applied again and again, change the natural rhythm of microbial life. Instead of symbiosis, there is dependency. Crops grow quickly, but the soil beneath them weakens. Its structure loosens, its moisture fades, and the web of bacteria and fungi that kept it fertile begins to collapse. Pesticides, too, brought their own revolution and their own shadow. Sprayed to protect crops from insects and disease, they seeped into rivers, settled into sediments, and spread through the food chain. The chemicals do not stop where they are sprayed. They drift on wind, wash into streams, and accumulate in bodies of creatures that never touched the fields at all. Insects vanish not only from farms but from forests and meadows beyond. Amphibians, whose skin absorbs the world around them, weaken and die in contaminated waters. Even birds, far from the fields, feel the weight of this invisible dust. Their eggs thin, their numbers fall. What was meant to defend life has, in many ways, divided it. The same story plays out in the rivers that carry the runoff of this age. Nutrients from farms pour into lakes and coasts, feeding explosions of algae that choke the water of oxygen. Fish die, not from poison, but from suffocation. Entire stretches of sea, in the Gulf of Mexico, in the Baltic, in the South China Sea, now turn seasonally into dead zones, where nothing can live except microbes that thrive in decay. The irony of it all is quiet but profound. In trying to control nature, we have unbalanced it. Fertilizer that once saved harvests now runs off in excess, creating blooms that kill. Pesticides that once defended fields now linger in the bodies of animals, in raindrops, even in the snow that falls in remote mountains. Beneath the surface, another transformation unfolds, one that cannot be seen from above. Soil is no longer as alive as it once was. Scientists call this process soil death. It does not mean the earth itself disappears, but that its living part, the thin layer of microorganisms and roots that gives it breath, fades away. Without this living network, soil loses its ability to hold water, to cycle nutrients, to support growth. It becomes dust. In places once known for their fertility, this quiet dying spreads. Vast farmlands depend on synthetic inputs to stay productive, yet every harvest takes a little more life from the ground than it returns. The earth grows tired. The rain that once nourished it now washes it away. Rivers run brown after storms, carrying the planet's most precious layer toward the sea. Even heavy metals, drawn from industry and mining, have found their way into this living skin. Mercury, lead, and cadmium settle into sediments and accumulate in crops. The soil remembers everything we pour into it. Nothing truly disappears, and yet the ground still tries to heal. In places left alone, microbes return. Fungi spin new filaments through the soil, reconnecting the threads of life. Earthworms, those small architects of fertility, slowly rebuild the texture of the land. The planet's patience is astonishing, but even patience has limits when the pace of change is relentless. To walk barefoot on healthy soil is to touch something ancient, a collaboration between time and decay, death and renewal. It smells rich, like rain and wood, a fragrance born from life breaking down into life again. But in many parts of the world, that scent is fading, replaced by the dry dust of fields that have forgotten how to breathe. The chemical age began with promise, with the belief that we could outsmart scarcity. For a while, we did. But in feeding ourselves, we have also starved the planet's oldest living system. The soil beneath us is still there, still waiting, but its pulse has slowed. We have learned to cultivate abundance, yet we have not yet remembered how to keep it alive. The earth still cradles us, even poisoned and weary. But to listen closely now is to hear not only the hum of life, but the faint, uneasy silence where once there was endless growth. If the story of Earth were written in layers of stone, each age would leave behind its own signature. The ancient seas left limestone, the forests of the Carboniferous left coal, the great extinctions left thin bands of ash and metal. And one day, when the rocks of our age are turned by time, there will be another layer, not of coral or bone, but of something glossy, light, and everlasting. Plastic. It began as a marvel, a triumph of chemistry and imagination. In the early 20th century, scientists found a way to transform oil and gas into a material that could be molded into anything. It was light yet strong, flexible yet durable, and resistant to decay. Humanity called it progress. The world filled with it, from toys to tools, clothes to computers. It became the quiet skeleton of modern life. But no invention stays innocent when it outgrows its purpose. Plastic was made to last, and last it does. Nearly every piece ever created still exists somewhere, drifting in the sea, buried in the ground, or waiting in landfills where it will outlive its makers by centuries. Unlike wood or metal or bone, it does not return to the earth. It only breaks apart, fragment by fragment, until it becomes too small to see, but never truly gone. Every bottle and fragment is a fossil of the future. If future geologists were to study our time, they would find plastic embedded in riverbeds and coastlines, in mountain snow and ocean trenches. It would be our unmistakable calling card, a thin, shimmering layer marking the Anthropocene, the age of humans. In some parts of the Pacific, the sea has gathered vast spirals of floating debris. Sunlight and waves grind the fragments into smaller pieces, creating clouds of plastic dust that drift through the water. Fish mistake them for food, birds feed them to their chicks, turtles swallow them whole, and the plastic, patient and persistent, climbs through the food chain until it reaches us. Scientists have now found microplastics in almost every corner of the planet. In Arctic snowflakes that fall over frozen seas, in the soft rain that washes over cities, even in the air we breathe, these particles, too small to see, move through the world like invisible pollen of a new age. They settle into the soil, into rivers, into the lungs of living things. Inside the human body, plastic has crossed the final boundary. It has been found in blood, in lungs, in the placenta that nourishes life before it begins. We do not yet know what this means for our health, only that the material we once thought of as separate from nature is now part of us. The maker and the made are intertwined. In the quietest places on Earth, where no cities rise and no ships pass, plastic still arrives. It drifts with the wind, floats with the currents, rides the rain. In deep ocean trenches 7 miles below the surface, researchers have found plastic fibers tangled among the sediments. On the peaks of the Himalayas, where air thins and snow never melts, microscopic fragments rest beside ice crystals. Even in the most remote corners of Antarctica, a few stray particles gleam beneath the microscope's lens. The scale of it is difficult to grasp. By weight, the mass of plastic ever created now surpasses the combined weight of all living mammals on Earth. There are more fragments of it on the planet than there are stars visible in the night sky. It has become the new sediment of civilization, a substance so common that it feels invisible until you look for it, and then you see it everywhere. And yet, there is something almost poetic about its persistence. Plastic is, in a way, our mirror. It reflects both our creativity and our carelessness, our ability to shape the world and our inability to let go of what we have made. It began as a symbol of possibility and convenience, but it has become a record of excess, a monument to permanence in a world built on change. Some scientists now speak of the Plasticocene, a time defined by synthetic geology. They study how future rocks, millions of years from now, will form with plastic fused into their grains, new hybrid stones born from sand, shell, and polyethylene. The process has already begun. Along beaches where waves pound debris against volcanic sand, small pebbles of plastic rock have appeared, bright with color, smooth as glass. They are called plastiglomerates, the first true fossils of our era. The irony is that plastic, which was created to make life easier, now makes the planet heavier. It clogs rivers, tangles forests, suffocates oceans. Yet beneath all of that lies a strange truth. It will endure long after we are gone. While metal rusts and paper fades, plastic remains, a ghostly testament to our brief and restless age. One day, when the world has moved on and new layers of stone have settled above us, some distant species may find traces of this strange material. They might wonder what kind of beings left behind so much color, so much permanence, and why those beings filled their world with something that could never die. The plastic epoch is still unfolding. It glints in the light of every bottle, whispers in the creak of every wrapper, and rides the wind across continents. It is both the mark and the memory of humanity's reach, a material born of the earth that forgot how to return to it. And so, the planet carries our story now, pressed into its soil and sea. Every bottle, every fragment, every grain of synthetic dust is a signature we have left behind, the quiet record of a species that learned to make eternity and scattered it to the wind. The story of life on Earth has always unfolded in slow motion. Even the great revolutions, the rise of oxygen, the bloom of forests, the fall of the dinosaurs, took place over spans so long that no creature could feel them happening. The planet has always moved at a pace that belonged to eternity, where each change was measured in the patience of stone, the rhythm of tides, the long breath of mountains. But now, that rhythm is breaking. The clock that once ticked softly through the ages is speeding up. For most of Earth's history, extinction followed a steady pattern, a background hum in the grand music of evolution. Species appeared, flourished, and eventually faded, replaced by new forms that inherited their place in the world. The balance was constant, but never still, a quiet turnover shaped by time itself. On average, it might take 1,000,000 years for a single species to vanish. It was a slow trade between creation and loss, a rhythm so gentle that the earth could heal as it changed. Life always had time to adapt, to evolve, to try again. Now, that pace has shifted by 1,000-fold. Scientists estimate that modern extinction rates are roughly 1,000 times faster than the natural background. What once took 1,000,000 years can now happen in a century. Creatures that have existed for tens of millions of years are vanishing within the span of a single human lifetime. Life is trying to keep up with a planet that's changing in fast forward. This acceleration is not loud, not explosive like the asteroid that ended the Cretaceous. It is a quiet cascade, a collapse of timing. Evolution is not built for such speed. The processes that shape life, mutation, selection, adaptation, work in generations, not in decades. When environments shift too quickly, species that once thrived find themselves stranded in time, perfectly suited to a world that no longer exists. The great forests, for example, still grow on the rhythms of ancient climates. Trees that once took centuries to mature now face droughts, fires, and temperatures they were never meant to withstand. They cannot simply migrate or evolve in a few human years. The roots that once anchored them now tie them to a world that is slipping away beneath their leaves. In the oceans, coral reefs are built on patience, each generation adding a few millimeters of growth, a small inheritance to the next. But the seas are warming and acidifying far faster than they can adapt. What took thousands of years to build can vanish in one summer of heat. Even the smallest creatures, the ones that have always survived by changing quickly, now face pressures beyond their limits. Insects that once synchronized their life cycles with flowering plants find those blooms arriving too early or too late. Migratory birds follow instincts written by thousands of years of stable seasons, only to find the insects they rely on gone, the weather unrecognizable. It is as if the planet's clock has been set to a new tempo, and everything living must dance to it, whether it can or not. The acceleration is not only biological but geological. Mountains erode faster as storms intensify. Glaciers that took millennia to form melt in decades. Rivers change their courses, coastlines retreat, and entire biomes shift northward, chasing cooler air. The land itself is hurrying through transitions that once unfolded in deep time. Humanity, in its ingenuity and restlessness, has become a force equal to volcanoes, to tectonic plates, to the movement of stars. We dig, burn, build, and consume at a speed the planet has never known. Every road, every city, every field replaces habitats that took millions of years to evolve. The Earth has always changed, but never this quickly, never everywhere at once. This is what scientists sometimes call the acceleration problem. It is not just the scale of change, but the compression of time, the way centuries of natural evolution have been squeezed into the space of a few human generations. The biosphere is being rewritten faster than life can read its own script. To understand how dramatic that is, imagine a vast forest as a living library. For millions of years, each species writes its story in the pages of bark and leaf, feather and scale. Evolution turns the pages slowly, adding and revising with care. But now, the pages are being torn out and replaced before the ink has dried. The new stories have no time to find their endings. The planet is still full of beauty. Sunlight still filters through green canopies. Whales still sing across the depths. The earth still spins beneath skies that seem eternal. But beneath that stillness, the tempo has changed. It is the difference between a river's steady flow and a flood that sweeps away its banks. In the fossil record of the future, this era will appear as a razor-thin line, a layer marked by sudden loss and rapid transformation. To the rocks that form millions of years from now, our age will look like a bit flash, a moment when life stumbled against the limits of time. And yet, there is something profoundly human about this acceleration. It is the product of our energy, our invention, our endless movement. We have harnessed time itself, compressed it, twisted it, used it to build everything we see. The machines, the cities, the technology, all of it is born from our desire to move faster. But the rest of life cannot keep our pace. The earth was not made for speed. Its balance is written in slow exchanges, the turning of soil, the drift of continents, the crawl of evolution. When that balance is forced to race, it falters. Life will continue, as it always has, but what it becomes next will depend on whether time itself can slow again, even for a moment, long enough for the living world to catch its breath. For now, the planet still spins, the seasons still change, and the winds still carry the songs of birds that remain. But if one listens carefully, beneath the hum of human progress, there is another sound, the quickened heartbeat of a world running out of time to adapt. For most of history, extinction was something invisible. Species faded quietly, leaving behind no witnesses, no record of the moment they were gone. A bird might stop singing in a distant valley. A flower might fail to bloom one final season. A reef might crumble into sand, and no one would ever know that the last of something had passed. But today, we are watching the planet's living fabric unravel, not through the naked eye, but through the careful gaze of machines, numbers, and memory. The story of life's disappearance is being written in data. In laboratories and research stations around the world, scientists have become the keepers of that record. They listen to forests through microphones that capture every call, every whisper of wings. They track herds by satellite, watching their movements shrink year by year. They count coral colonies from above using drones, noting where color has turned to gray. Even space itself has become an observatory for life, as satellites orbiting the planet map the greenness of Earth and measure how it dims. The scale of what they see is both vast and intimate. Every species, every population, every small fragment of change becomes part of a larger picture, a mosaic of decline. At the heart of this record lies something known as the IUCN Red List, a kind of global ledger for the living. It is where scientists gather the names of all known species and mark their status: least concern, vulnerable, endangered, critically endangered, extinct in the wild, extinct. It is a catalog of both presence and loss, a testament to how fragile abundance has become. But even these names are a kind of echo. The moment we label a species as endangered, we may already be too late. There is a quiet phenomenon in ecology called extinction lag. It describes the delay between the moment a species begins to disappear and the moment we finally notice. It is the space between silence and understanding, between vanishing and recognition. Imagine a small bird that lives only on one island. Its forest is cut down, its food grows scarce, its numbers fall, but a few individuals remain. Years pass. Scientists visit, searching for signs, and they find none. Yet somewhere in the forest, one bird still lives, unseen. For a while, it exists in a kind of twilight, alive in the present but already gone in the eyes of the world. By the time its absence is proven, its story is already over. Extinction lag is not just about species, it is about systems. Coral reefs can appear alive long after they have lost their living foundation. Forests can stand tall while their soil, stripped of nutrients, is quietly dying beneath. Even the oceans can look full of motion while their ecosystems hollow out, layer by layer. What we see often lags behind what is true. Part of this delay comes from scale. The natural world is immense, and change often hides within its vastness. It takes years to gather enough data to see a pattern, to confirm what instinct already whispers. A decline that feels local may in truth be global, but it takes time for the signals to align. By the time the data confirms it, the damage is often irreversible. To scientists, this lag is both a challenge and a heartbreak. They work with precision, measuring, documenting, comparing, but they are always looking slightly backward in time. Every graph is a reflection of what has already happened, not what is still to come. Each data point is a moment already past. In a way, the red list is not just a scientific tool, but a memorial. Each entry tells the story of a species struggling to remain visible. There are more than 40,000 names now classified as threatened. Some are famous: tigers, orangutans, elephants. Others are small and forgotten, known only to a few who studied them. A beetle from a single valley, a frog that once sang in mountain streams, a plant that bloomed in a desert no one visits anymore. For many, the data arrives too late. Populations can decline by 90% before the full picture becomes clear. By the time a species reaches the critical threshold for protection, its genetic diversity is often too thin to recover. Conservation begins in the shadow of loss. Yet within this vast archive of decline, there are also moments of persistence. Every so often, a creature thought extinct reappears, a bird photographed after decades of absence, a small orchid blooming again in forgotten soil. These rediscoveries are rare, but they remind us that even data cannot capture everything. Life has always held the capacity to surprise, to hide, to endure in the smallest cracks of time. Still, the trend is unmistakable. The world is emptying, quietly and mathematically. The numbers tell a story that the eye struggles to grasp. Populations shrinking by half in a generation, forests losing their song, rivers carrying fewer shapes of life. In the end, the work of tracking extinction is not just about loss, it is an act of remembering, of bearing witness to what is still here. Every data set, every observation is a way of holding on to life as it slips through the gaps of time. The data of disappearance is a mirror, not just of what is dying, but of how closely we are finally learning to look. And somewhere within those lines and graphs, beneath the precision of measurement, there is a quiet truth that no number can capture. The earth does not vanish all at once. It fades in increments, in unrecorded silences, in the spaces between what we know and what we notice. By the time we name a loss, it has already passed into memory. The world continues to turn, the satellites continue to circle, and the lists continue to grow. And within those records, the living planet leaves a trace of itself, not in fossils this time, but in data, in patterns, in memory, a digital echo of what was once alive. In the stillness of science, even the end of the world is not declared easily. It must be measured, verified, and questioned again. The word extinction carries the weight of eternity, and so the question of whether humanity has entered a sixth great dying is not one that scientists agree upon. It is a debate woven from evidence and emotion, from data and doubt. Some believe the signs are already undeniable. They point to the patterns, the vanishing species, the warming seas, the bleaching reefs, the silence spreading through forests and skies. They see the fingerprints of catastrophe in the fossil record of our time, and they call this moment what it appears to be, the beginning of the sixth mass extinction. Others are more cautious. They argue that while the rate of loss is alarming, it has not yet reached the full scale of the 5 ancient cataclysms that reshaped the planet's history. They remind us that extinction, though tragic, is also natural, that species have always risen and fallen, and that Earth has always evolved through change. Perhaps, they say, what we are witnessing now is not yet the end, but the brink, the truth. Like most things in nature, lies somewhere between. When scientists speak of a mass extinction, they mean more than a simple loss of life. They mean a collapse of ecosystems so vast that 70% or more of species disappear within a short geological time. Such events have occurred only 5 times in the planet's long history: the Ordovician, the Devonian, the Permian, the Triassic, and the Cretaceous, each one a reshaping of life's possibilities. To call the present a sixth is to say that humanity's impact has already matched those ancient upheavals. But the evidence is still forming, and the measurements of extinction are more complex than they appear. Not every disappearance leaves a fossil, not every loss is recorded. Many species vanish unseen, especially the small and the hidden, the insects, amphibians, and deep-sea creatures that rarely draw attention. The red list, with its 40,000 threatened names, may only be the visible edge of a much larger shadow, yet even this shadow is hard to define precisely. Some species thought extinct are found again, clinging to life in forgotten corners of the world. Others linger as names alone, known only through old specimens and fading photographs. This uncertainty fuels the debate. Are we already in the middle of a mass extinction, or are we merely accelerating toward one? The distinction matters, not just scientifically, but philosophically. To be in it suggests inevitability, a collapse already in motion. To be approaching it suggests choice, a narrow space of possibility still open to us. Those who argue that the sixth extinction has already begun point to the rate of loss. By comparing today's data with the background extinction rate of the past, they find that species are disappearing hundreds or even thousands of times faster than normal. By this measure, they say, the threshold has already been crossed. Those who hesitate counter that, while the rate may be extreme, the total scale is not yet there. Many ecosystems, though damaged, remain resilient. Forests regrow, populations rebound. Some species adapt in surprising ways. Evolution, after all, has always favored persistence. They remind us that the story is not finished, that to call it a mass extinction now is to write the ending before it has been lived. Between these two perspectives lies a tension that hums quietly through the scientific community. It is not a disagreement born of denial or ignorance, but of caution, the same careful restraint that defines good science. To name something as monumental as a mass extinction requires time, evidence, and distance, the very things that the living world can no longer afford. For those who study these patterns, the question is both analytical and deeply human. The data tells one story, the heart another. In the numbers, they see a downward curve. In the field, they see empty nests, quiet reefs, untraveled migrations. The evidence is heavy, but so too is the responsibility of naming it. And yet, the debate itself keeps something precious alive: curiosity. The question, is it too late or not yet, is not a cry of despair, but of attention. It means we are still watching, still listening, still measuring the pulse of the planet with care. It means we have not yet turned away. In the end, perhaps what matters most is not the label, but the awareness. Whether we are at the edge or already over it, the signs remind us that our time is intertwined with all others, that the fate of one species ripples through the rest. The earth has always changed, and life has always recovered, but never before has one species held the power to steer the outcome. We have become both observer and participant, the ones who keep the record and the ones who shape it. For now, the debate continues, steady and unresolved. Some papers end with warnings, others with hope. Some speak of collapse, others of resilience. All are written with the same quiet urgency, the same recognition that this is not just a scientific question, but a story unfolding in real time. The truth will not arrive in a single moment. It will emerge slowly, layer by layer, as the world continues to change. One day, the rocks may tell the answer, but until then, the uncertainty is its own kind of light, a reminder that the story of life is still being written, and that within that unfinishedness, there is still time to listen. When life falls, it does not rise quickly. The earth knows how to heal, but its kind of healing moves at the pace of mountains, not of moments. After every great extinction, when the sky cleared and the fires went out, the planet was left in silence, a silence so deep that even the wind seemed uncertain where to blow. Yet always, somehow, life returned. It came slowly, like dawn after a long night. The empty seas grew cloudy with drifting cells. The blackened land sprouted the first shoots of green. New creatures took tentative steps into spaces once ruled by giants. In each recovery, evolution began again, not as a repetition, but as a reinvention. The rules of survival were rewritten, and the world that followed was never the same as the one that had come before. But these recoveries came at a cost, measured in time, beyond human comprehension. After the Ordovician extinction, when the seas froze and oxygen thinned, it took tens of millions of years for coral reefs to reappear. After the Devonian, when oceans suffocated and forests fell, the earth remained quiet for nearly 50 million years before fish and plants reclaimed their variety. After the great dying of the Permian, the longest and most severe of all, it took more than 10 million years for ecosystems to rebuild the simple complexity that once existed in a single coral reef. Evolution always returns, but never for those who vanished. Each time, the planet began again from what little survived. Life's history is written not only in the triumphs of the survivors, but in the gaps left by what did not return. The creatures that once shaped the seas and skies became echoes, their absence opening space for new forms. After the Permian, reptiles flourished in the silence left behind. From them would come the first dinosaurs who would one day rule the earth. After the asteroid ended the Cretaceous, mammals rose from the shadows, inheriting a world that no longer trembled under the feet of giants. Every extinction, in its aftermath, gave rise to something new, smaller, stranger, and adapted to the new conditions carved by catastrophe. Yet, even as the earth remade itself, it carried the scars of what it lost. In the rocks, scientists can still trace the intervals of emptiness, long spans of geological time where biodiversity remained low, where entire ecosystems were simplified. The seafloors that were once alive with coral and shell lay barren. Forests that once covered continents regrew as sparse thickets. Recovery was never a sudden return to abundance, but a gradual filling of space, a reweaving of the web of life, one fragile thread at a time. The survivors themselves were changed by the struggle. The species that endured each mass extinction were often the small, the adaptable, the ones that could live anywhere and eat almost anything. They were not the rulers of the old worlds, but the quiet inheritors of the new. From their persistence came the next great chapters of life, but they bore no memory of what had come before. In this way, evolution is both merciful and merciless. It always finds a way to begin again, but it does not grieve. It builds upon what remains and forgets what is gone. The ammonites of the seas, the forests of the Carboniferous, the great reptiles of the Triassic, all gave way to new forms that did not remember them. The Earth's recoveries were not only biological, but chemical and climatic. After every collapse, the atmosphere had to restabilize. The balance of carbon and oxygen had to find a new rhythm. The ocean currents had to resume their circulation. Even microbes had to evolve anew to restore the invisible processes that make the planet breathe. It is these invisible recoveries, unseen yet essential, that make the difference between a world that can host life and one that remains lifeless. From the perspective of deep time, the patience of Earth is profound, but from the scale of our brief existence, its pace is almost unbearable. To imagine a recovery taking millions of years is to realize how brief our species truly is. The forests that vanish today may never return in any form we would recognize. The reefs that bleach white may take entire ages to rebuild. The animals that disappear in our lifetime are not simply lost for now, they are gone for the rest of human history. And yet, life itself does not despair. It endures. Even after the Great Dying, when 96% of marine life vanished, a few small organisms clung to the edges of survival. From them, the oceans began again. It was not the same ocean, nor the same life, but it was life all the same. The lesson hidden in these ancient recoveries is both humbling and haunting. The earth does not need us to survive. It has been broken before, and it has always found a way to heal. What it cannot do is heal quickly. For all its resilience, time is its medicine, and time is what humanity no longer gives. If this age is to end in another great dying, then recovery will come, but it will not come for us. The forests will eventually regrow, but they will not be the forests we knew. The oceans will fill again, but with creatures born from conditions we cannot imagine. Life will return, reshaped by its scars, indifferent to what it once was. And in some distant epoch, when the fossils of our age lie buried beneath new layers of rock, another intelligence, perhaps alien, perhaps evolved from what we leave behind, will find traces of us and wonder what kind of creatures could have changed the planet so completely, and then vanished into silence. For life always finds its way back, but never in the same form, never for those who disappeared along the way. Evolution endures, but memory does not, and the earth, as it always has, will move forward, quietly, patiently, into its next beginning. When the world begins to break, survival does not belong to the strongest. It belongs to the ones who can bend, who can hide, who can begin again from almost nothing. Every great extinction has proven this truth. When the great and powerful fall, it is the small, the quick, and the quiet that inherit the earth. In the aftermath of catastrophe, life's rules change. The creatures that once ruled the world by size or strength suddenly find those gifts turned against them. Large bodies need too much food, too much space, too much stability, but in an age of fire, flood, or famine, there is little of any of those things left to give. So evolution turns its gaze elsewhere, to the ones that can live with less. In the long recoveries that followed Earth's previous extinctions, the survivors were rarely the giants. They were the adaptable ones, small mammals that could sleep through drought, fish that could breathe in murky waters, insects that could feed on anything that remained. When the forests burned and the skies darkened, these were the creatures that found cracks to crawl into, burrows to wait inside, seeds to scatter into the soil. Flexibility became the new measure of success. The fossil record tells this story with quiet consistency. After the Great Dying, the largest reptiles vanished, but small, nimble forms took their place. After the asteroid that ended the Cretaceous, creatures no larger than a rat scurried from the ashes, hiding in shadows, feeding on roots and eggs, and outliving all that had towered before them. Rats, in particular, are a living reminder of what survival really means. They have followed us across every continent, learning to thrive in our waste, our cities, our warmth. They adapt faster than almost any other mammal, their diets and behaviors shifting with every new environment. They do not need beauty or grace to succeed, only persistence. Cockroaches share the same inheritance. They existed long before humans, long before dinosaurs, and they have changed little since. Their armor is thin but resilient, their needs few. They can eat glue, paper, dust, and even survive for days without food at all. Where other species perish from precision, needing the perfect climate, the perfect balance, cockroaches live by simplicity. Plants have their survivors too. After volcanic winters and global droughts, some of the first green to return to the land came from the simplest of seeds. Ferns, grasses, and weeds sprouted in places where forests had fallen. Their secret is patience and abundance. Each seed carries thousands more within it, ready to take root wherever there is a trace of moisture and light. They do not demand perfection, only possibility. Life finds a way, but not always beautifully. In the face of extinction, elegance fades. The delicate coral that needs a narrow band of temperature, the bird that sings for only one kind of mate, the orchid that blooms for a single bee. These wonders are fragile by design. The survivors are not the rare or the refined, but the generalists, the opportunists, the ones that can live in chaos. In modern times, these traits still hold their quiet power. The creatures that flourish alongside humans, pigeons, rats, weeds, and stray dogs, are not loved, but they endure. They live in our ruins, eat what we leave behind, and find warmth in our shadows. Evolution, indifferent as ever, rewards only endurance. There is a kind of poetry in this, even if it is not the kind we hope for. It reminds us that life does not need perfection to persist. It can survive on the margins, in cracks of concrete, in polluted streams, in cities that never sleep. In places where the natural world seems to have ended, life begins again in unexpected forms. Adaptability, In the language of nature, is resilience made flesh. Some creatures adapt through their bodies, shorter generations, faster breeding, wider diets. Others adapt through behavior, learning to live alongside new threats, new climates, new sounds. Crows drop nuts onto roads for cars to crack open. Foxes learn to hunt through human garbage. Plants shift their flowering seasons to match the changing heat. Even bacteria, invisible but eternal, rewrite themselves in real time, altering their very chemistry to survive poisons meant to end them. Their world is microscopic, yet their strategy is the same as it has always been: adjust, endure, evolve. This has been the rhythm of every age. The powerful rise, the delicate flourish, and then collapse clears the stage. What remains are the quiet architects of the next beginning. From them, new worlds are born, not planned, not beautiful, but alive. Perhaps the survivor's greatest gift is not just adaptability, but indifference. They do not mourn the old world. They do not cling to what was lost. When the forests fall, they move into the clearings. When the seas grow toxic, they swim closer to shore. Life does not wait for conditions to improve. It simply continues wherever it can. In this way, every extinction is also a mirror of persistence. The shapes that endure may be humble, but they are the threads from which the next tapestry will be woven. Evolution, patient and impartial, builds from what remains. And so, when the world changes again, as it always does, it will not be the mightiest that inherit what follows. It will be the quiet survivors, the ones that find life in the ruins, small, swift, and adaptable, the same formula that has saved life 5 times before. Because the truth of survival has never been grandeur or strength. It has always been this: the ability to begin again when the world forgets how to be kind. For millions of years, life on Earth evolved through forces far beyond intention. Volcanoes, meteors, ice, and time itself were the architects of change. But now, there exists a creature that shapes the planet by thought, by choice, and by consequence. A species capable of destruction on a global scale, and yet also capable of compassion, of care, of choosing to protect what remains. That species is us. The human story is one of contradiction. We build cities from the bones of forests. We drain rivers to grow food, then spend years trying to bring the water back. We study the same animals we endanger, mourn the beauty we destroy, and invent ways to save the world we have wounded. We are the only species to know what extinction means, and still the only one who can stop it. The paradox is written into everything we do. In one breath, we have remade the world. Forests cleared for farms, mountains carved for metal, oceans filled with the weight of our waste. Creatures that once ruled, entire continents now survive in fragments of wilderness or behind fences. Yet in another breath, we build sanctuaries, restore coral reefs, and guard the last of the great herds. We destroy, and then we heal. Perhaps this is what makes humanity both terrifying and extraordinary: the capacity to do harm and the awareness to regret it. There was a time, not long ago, when the idea of conservation did not exist. The seas were seen as endless, the forests as infinite, whales were hunted for oil, their bodies turned into light for human homes. By the 19th century, the oceans that once thundered with their songs had fallen silent, populations of blue whales, the largest creatures ever to live, dropped by nearly 90%. But something changed. People began to listen. They realized that even giants could disappear. By the late 20th century, whaling bans spread across the world. It took decades, but the seas began to stir again. Off the coasts of California and Iceland, the songs of whales slowly returned. Their populations are still fragile, but they endure. living proof that when humanity decides to stop, the earth has a way of breathing again. The same story unfolded in the skies above. In the middle of the 20th century, the bald eagle, a symbol of power and freedom, was vanishing from the very land it represented. The culprit was not hunting, but chemistry, a pesticide called DDT that thinned eggshells until they cracked before hatching. Forests emptied of their silhouettes. Lakes that once reflected their wings fell silent. Then, people noticed. Scientists studied. Lawmakers acted. DDT was banned. Nesting sites were protected. And within a generation, the eagles returned. They nested again in tall pines and along rivers, rebuilding what had nearly vanished. Their recovery became one of the most powerful examples of what human restraint can accomplish. Not all rescues are from distance, some are quiet and intimate. In the forests of Yellowstone, wolves were reintroduced after 70 years of absence. Their return reshaped the land in ways no one predicted. With wolves back, elk herds moved differently, allowing young trees to grow where they had been eaten down for decades. Streams grew cooler under new shade. Beavers returned, building dams and creating new habitats. One species restored balance across an entire ecosystem, and in the sea, divers have become gardeners. Across tropical waters, people now plant coral nurseries, delicate fragments of living stone tethered to ropes and frames beneath the waves. Slowly, they grow, spreading color across the reefs once bleached and dead. It is not a full restoration, not yet, but it is a beginning. These are glimpses of the other side of the human story. Every act of destruction leaves an echo, but every act of care leaves one too. A single rescued species can awaken empathy in millions. A single forest saved can shelter thousands of others unseen. Humanity, at its best, is capable of something no extinction event before ever had: reflection, the ability to understand cause and effect and to change direction before the final page is turned. No other species has ever had the choice to stop an extinction. The paradox is that we are both the storm and the shelter. We have set the fires and built the refuges. We are the reason coral reefs fade and the reason some still glow again. We are the makers of plastic and the inventors of cleanup machines that trawl the ocean's gyres. We are the cause of rising seas and the dreamers who build floating cities to endure them. What makes this moment unique in Earth's history is not only the damage done, but the awareness of it. We know the weight of our actions. We can measure the heat rising, count the animals lost, trace the smoke of every forest burned. This knowing brings responsibility, and in that, a strange form of hope. When we choose to protect rather than consume, the results can be astonishing. The ozone layer, once thinning toward catastrophe, is now healing because nations acted together to ban harmful chemicals. Endangered species, from humpback whales to mountain gorillas, are rebounding under careful protection. These are not miracles, they are choices, deliberate acts of attention, compassion made visible. Still, the paradox remains. For every success story, another loss unfolds. New threats rise as old ones fade. Yet the fact that we can save anything at all, that we can notice, decide, and act, means the future is not fixed. In the deep past, life had no say in its fate. Volcanoes and asteroids offered no second chances. But today, the deciding force walks upright, looks to the stars, and holds the memory of every age in its mind. We are both the danger and the remedy, both the ending and the possibility of something that has never happened before, an extinction paused by the very species that caused it. And if life continues beyond this moment, it will carry the memory of us, a paradox written into its survival, a species that once broke the world and then tried to help it heal. There is a strange kind of hope being kept in the cold. in quiet bunkers buried beneath mountains, in vaults guarded by frost and silence, humanity is storing what remains of life, not in living forests or wild seas, but in jars, vials, and sealed steel chambers. It is as if we have learned that we cannot stop time, so we have begun trying to preserve it instead. Across the world, there are places where life has been gathered, catalogued, and frozen. Seeds of trees that once shaded entire valleys, grains that fed civilizations, flowers from mountain slopes that bloom only once a year, each one carefully labeled, dried, and sealed in silver packets, resting in the stillness of artificial winter. Perhaps the most famous of these sanctuaries lies deep in the Arctic, carved into the side of a mountain on an island called Svalbard. The air outside is silent, the ground buried beneath snow, the horizon lit only by the faint glow of polar light. Inside, behind heavy steel doors and thick walls of permafrost, lies the Svalbard Global Seed Vault, a library of potential futures. Inside its chambers are more than 1 million seed varieties, collected from almost every country on Earth. Rice from Asia, wheat from Africa, maize from the Americas, barley from Europe, each one a story of adaptation, the record of how life has learned to survive across climates and centuries. Together, they form a quiet chorus of possibility, a backup of the biosphere. The vault was built not for today, but for tomorrow. It exists for the moment when crops fail, when war or disaster wipes out a region's agriculture, when a changing climate turns familiar soil into dust. In that moment, a packet from Svalbard can be opened, planted, and life can begin again. It is a simple idea, but one of quiet brilliance, to safeguard diversity not by fighting time, but by outlasting it. Yet seeds are only part of what we are saving. Across other hidden facilities, humanity is preserving the very essence of species, their DNA, frozen in liquid nitrogen at temperatures colder than any natural place on Earth. These cryogenic archives store fragments of the living world in microscopic detail. In laboratories, technicians wear gloves so thick they cannot feel the samples they hold. They handle vials that shimmer faintly in the frost, each containing strands of genetic memory, the blueprint of elephants, frogs, orchids, coral, and countless others. Some of these creatures are endangered, others already gone, but in the frozen dark, their code endures, waiting for a world that might one day be ready for them again. These collections are known by many names: the Frozen Ark, the Cryobank, the Millennium Seed Bank. Together, they form a vast, quiet network of memory, a backup of evolution itself. Humanity, in its urgency, has become the planet's archivist. In museums, scientists store bones and feathers, shells and leaves, fossils and skins. In freezers, they store blood and tissue, cells and embryos. In computers, they store the sequences of life in digital form, billions of letters of code compressed into data carried on drives smaller than a hand. We are recording the world as it slips through our fingers. We are trying to freeze time, literally. Perhaps it is instinct, the same impulse that made us paint on cave walls and carve names into stone has evolved into something vast and technological. We fear forgetting, and so we preserve. We fear loss, and so we gather. In this way, even as the living earth changes faster than we can heal it, we create stillness, small sanctuaries against oblivion. The seeds resting in the cold do not know the world has changed. To them, it is simply a long winter. One day, if they are warmed again, they will awaken, stretch toward light, and grow as they always have. In that moment, they will not remember the humans who saved them or the reason they were frozen. They will only know how to live. We are archiving life for a future that may not remember us. There is something quietly beautiful in that idea, that even if our time on Earth is brief, something of us might remain, not in monuments or machines, but in the living things we protected. The future may never know our names, but it may breathe air filled with the scent of forests reborn from our frozen seeds. The act of preservation is not only about control, it is also about humility. We are acknowledging that the planet's balance is fragile and that we are part of what endangers it. But we are also acknowledging something deeper, that the continuity of life matters, even without us in it. In the far future, when ice melts and landscapes shift, perhaps someone or something will find these vaults. They might open them not with reverence, but with curiosity. They may never understand the fear that built them, the care that filled them, or the hope that sealed them shut. But when they plant those seeds and life blooms again, they will become part of the same story we began, the endless cycle of loss and return. Inside the frozen mountain, the air never moves. Lights hum softly, keeping the temperature constant. Rows of seeds sleep beneath frost, each one a promise suspended in time. Outside, snow drifts quietly against the door, and above the polar sky, stars wheel through the darkness, as they always have. Life waits patiently, and in that stillness, we have given it one more chance. Far beneath the cities we build and the skies we cloud, the earth is quietly keeping record. Every era of life leaves its signature written into stone, a thin line of fossils, a layer of ash, a whisper of chemistry in the rock. One day, long after our time has passed, the same will be true for us. There will be a human layer in stone. Scientists have a name for it, the Anthropocene. It is a word meant to describe a new geological chapter, one shaped not by volcanoes or asteroids, but by a single species, ours. For the first time in Earth's history, life itself has become a force of geology. Future geologists, whoever or whatever they may be, will find our signature easily. They will see it in the ground beneath our feet, in the sediments settling now across every continent and sea. It will not be a subtle trace. It will be a line bright and unnatural, filled with materials that nature never learned to make. They will find plastic first. No other material defines our age so completely. It is everywhere, from the depths of the ocean to the peaks of the Himalayas, from Arctic snow to desert sand. Plastic does not rot or rust or fade. It only breaks into smaller and smaller pieces, each one light enough to travel with the wind or the rain. It now falls from the sky with every storm, drifts in rivers like strange pollen, and gathers on seafloors like sediment. In millions of years, long after the waves and weather have buried it, plastic will remain. It will harden into rock-like layers, fused with sand and shells and fragments of glass. Scientists have already found these hybrid stones along coastlines. They call them plastiglomerates. One day, they may form a recognizable boundary in the rock record, a mark as clear as the thin layer of iridium that tells of the asteroid that ended the age of dinosaurs. That is how future scientists will know us. By our debris. Alongside plastic, they will find metal, aluminum, copper, and steel, spread across the world, in quantities nature never produced, cables buried beneath cities, fragments of cars and buildings pressed into the soil, even tiny traces of metal dust drifting in layers of ice. These materials, once mined from the Earth's crust, will return to it, not in the slow cycle of erosion, but as a flood of alloys and composites that no natural process could create. And deeper still, another sign will rest in the rock, one both invisible and enduring. In the middle of the 20th century, humanity began splitting atoms. The age of nuclear energy and weapons left a fingerprint finer than dust, yet more permanent than stone. Radioactive isotopes from nuclear tests drifted around the planet, falling in rain, snow, and soil. They became part of the sediment, embedding themselves into layers that will last for tens of thousands of years. When those future geologists study the strata of our time, they will see a spike in radiation unlike anything before or after. A pulse in the rock that says, "Here they were." The earth does not judge what it records, it simply remembers. The Anthropocene is not just a geological idea, it is a mirror. To see it clearly is to realize how deeply our lives have become intertwined with the planet's materials. Every piece of concrete, every bottle, every fragment of circuitry we leave behind becomes part of the planet's evolving skin. We have changed the chemistry of air, the texture of soil, the color of rivers. Even our cities, viewed from above, form patterns that rival coral reefs in complexity, vast ecosystems of glass and steel humming with light. And yet, for all our movement and invention, what will endure longest of us is not our monuments, but our residue. Plastics, metals, carbon, nuclear dust, the fingerprints of a civilization that built quickly and left widely. There is something both haunting and strangely comforting in that thought. Long after our names are forgotten, the earth will still hold a trace of us, not as fossils of bone, but as fossils of intent. We will exist in the composition of rocks, in the chemistry of oceans, in the thin geological line that separates what came before us from what will come next. If the past is any guide, new life will one day grow above that layer. Grasses will root in it, rain will fall across it. Perhaps a new kind of intelligence, born of some distant future, will dig into the ground and study it, wondering what kind of beings we were. They will find our plastic, our metal, our radiation, and perhaps a few bones of the species that once remade the world in its image. And what will they think? Maybe they will see both sides of us, the builders and the destroyers, the creators of beauty and waste, the species that understood its impact but struggled to stop it. They might not know our languages or stories, but they will know that we changed the earth faster than any force before us. They will know that for a brief moment in deep time, life itself learned how to alter the planet's course. Every age leaves a mark. The dinosaurs left bones, the ice ages left grooves in stone, and we, the modern humans, will leave a layer, thin, strange, filled with traces of our imagination and our excess. It will not glitter with gold or marble, it will glitter with plastic, it will hum faintly with isotopes, it will carry the memory of concrete and the shimmer of silicon dust. The planet will move on, as it always has. Mountains will rise, oceans will shift, and our layer will sink deeper, compressed into a future rock that will one day be broken open by hands that are not our own. And when that day comes, the earth will whisper through its stones the same truth it always has, that everything which lives leaves something behind. There was a time when every human step touched soil, when every dawn began with birdsong and the scent of wet grass, when the world outside was not something visited, but lived within. Now, much of that closeness has quietly faded. The wild, once an endless presence surrounding us, has retreated to the edges of memory. Forests have become destinations, not neighbors. Rivers are crossed by bridges, not by feet. The stars that once guided travelers are hidden behind the glow of cities. We no longer walk among the living world. We scroll past its memory. Across the surface of Earth, the shape of human life has changed. More than half of all people now live in cities, and each year that number grows. Where meadows once stretched toward distant hills, buildings now rise in rows of glass and steel. The hum of insects has been replaced by the hum of electricity. The night air glows with the pulse of artificial light, erasing the boundary between day and darkness. This transformation is not just physical, it is emotional, even spiritual. It has created what some scientists and writers call the extinction of experience. It means that as the natural world disappears, so too does our direct connection to it. We see fewer species, hear fewer songs, feel fewer textures of wind and rain. Children who grow up in dense cities may never climb a tree, never touch soil that has never been paved, never know the difference between the call of a sparrow and a swallow. To them, nature becomes something abstract, something seen through screens, not senses. The consequences of this distance ripple quietly through our lives. When people no longer feel part of the living world, it becomes easier to forget it needs care. When forests are known only as pictures, their loss feels less real. When rivers are hidden underground or fenced behind concrete, their slow pollution passes unnoticed. The extinction of experience feeds the extinction of life, not from cruelty, but from absence, from the simple fact that we no longer see what is vanishing. It is not that cities are lifeless. They have their own rhythms, their own kinds of beauty. Moss grows between cracks in the pavement. Pigeons roost under bridges. Foxes and raccoons wander alleys under the moonlight. Even in the densest streets, life finds its way in, small, resilient, unnoticed. Yet for all its persistence, this kind of nature feels like an echo, not a conversation. Once, human senses evolved alongside the earth. Our eyes adjusted to the colors of dawn and dusk. Our ears attuned to rustling leaves, the rush of water, the murmur of wind through tall grass. Our sense of time itself was shaped by the rhythm of seasons. To lose that closeness is to lose a part of ourselves, a quiet understanding of balance. Now, instead of listening to the rain, we listen to recordings of it. Instead of standing beneath trees, we view them through photos, framed and filtered. The wild has become a form of nostalgia, something we recreate in gardens and parks, tidy and controlled, small enough to manage, but never enough to replace what was once infinite. Even the word wild has shifted. It once meant freedom, abundance, and the unknown. Today, it is used to describe what remains outside the grid, the leftover spaces that civilization has not yet filled. The wilderness, once everywhere, now survives in fragments, national parks, reserves, and the few places too cold, too high, or too deep to be settled. We have turned the living planet into a mosaic of managed patches, and ourselves into visitors within it. And yet, something in us remembers. When we see a tree break through concrete, we pause. When birds gather at dusk, wheeling across the sky in black patterns of motion, we still look up. When we walk by the sea, the rhythm of waves feels familiar, as if it were echoing something ancient within us. The connection is not gone, only buried beneath the noise. Some people are beginning to rediscover it. Urban gardens rise on rooftops. Old railway lines are transformed into green paths where grasses grow between the steel. Schools bring children into forests again, teaching them not just the names of animals, but the feeling of belonging among them. Scientists are studying how even short moments in nature, the sight of trees, the sound of flowing water, can calm the human heart, slow the pulse, ease the mind. It seems the wild has not truly vanished. It waits patiently, not just in distant forests, but in the cracks and corners of our lives. In every small act of noticing, it begins to return. Still, something profound has shifted. The relationship that once defined our place on earth has grown thin. We have built walls of light and noise around ourselves, and in doing so, have forgotten the language that once connected us to everything alive. The extinction of experience is quiet, but it may be one of the most significant losses of all, not because it erases species, but because it erases awareness. It leaves us adrift, surrounded by our own creations, unable to see the roots we still depend on. Somewhere, Beyond the glow of the cities, the world remains vast and alive. Trees still breathe, oceans still move, mountains still rise against the horizon. The living earth is still there, waiting, unchanged in its patience. We may have forgotten how to walk among it, but it has not forgotten us. It still calls softly in the wind, in the rustle of leaves beyond the edges of light, reminding us that we were never separate, only distracted. Everything alive is connected, though we rarely see the threads. They stretch across oceans and forests, between soil and air, from the smallest cell to the largest creature. It is a web woven over billions of years, so intricate and balanced that the survival of one depends quietly on the health of many. The earth breathes through this web. Every leaf, every feather, every drop of water plays its part. In nature, nothing exists alone. A coral reef, for instance, is not just a structure beneath the sea, it is a city of relationships. Tiny coral animals build limestone homes that shelter fish, crabs, and worms. In return, the algae living inside their tissues feed them through sunlight. Each species depends on another, forming a cycle of life that looks effortless but is fragile beyond measure. If the water grows too warm, the algae leave, the corals turn white, and an entire community begins to collapse. What looks like one dying organism is in truth the unraveling of thousands. Forests tell the same story in a different language. Beneath their roots lies a network so vast that scientists call it the wood wide web. It is formed by fungi that connect tree roots together, passing water, nutrients, and even signals from one tree to another. Through this underground exchange, a mother tree can nourish her seedlings or warn her neighbors of danger. The forest is not just a collection of trees. It is a single breathing organism made of many minds, linked in silence. This is how life on Earth survives, not through isolation, but through connection. Some species hold this balance more tightly than others. Scientists call them keystone species, for they act like the central stone in an archway. Remove it, and everything else begins to fall. Sea otters are one of these quiet keystones. By hunting sea urchins, they keep kelp forests alive. Without them, urchins multiply endlessly, devouring the kelp until nothing remains but barren rock. On land, wolves play the same role. When wolves disappeared from Yellowstone, deer and elk spread unchecked, stripping valleys bare. When they were reintroduced, the balance returned. Trees grew again, rivers changed their flow, and birds came back to nest. One species reshaped an entire landscape simply by being present. In the Arctic, polar bears keep seal populations in check. In African plains, elephants clear paths that allow grasslands to breathe. In tropical jungles, fruit bats carry seeds far from their trees, giving birth to new forests with every flight. Each one is a thread in the same vast design, holding tension, carrying weight. And yet, these connections are delicate. When one thread breaks, the whole web trembles. The extinction of a single insect can silence the flowers it pollinates. The loss of those flowers can starve the birds that eat their seeds and the animals that feed on those birds. Slowly, invisibly, the balance tilts. In the history of life, this has happened before, but never at such speed, and never with one species pulling so many strands at once. Humans often see themselves as standing outside this web, watching it from a distance. But we are part of it too. Our breath carries oxygen made by plants. Our food depends on bees, soil microbes, and the health of the seas. Even the air we breathe is shaped by invisible organisms drifting in ocean water. For every city, every meal, every heartbeat, there is a quiet chain of life beneath it. When ecosystems falter, we feel the tremors. A collapse in coral reefs leads to empty fisheries. The disappearance of pollinators threatens global food supplies. Deforestation changes rainfall patterns across continents. These are not isolated tragedies. They are echoes of the same broken thread. But within this fragility lies something profound: resilience. Ecosystems have always adapted, though slowly and at great cost. After each mass extinction, life has learned to rebuild the web anew. It takes millions of years, but the pattern always returns, shaped by new connections. Even now, there are signs of endurance. Some coral species are learning to tolerate warmer seas. Forests regrow when given space and time. Wolves, beavers, and whales, creatures once nearly erased, are slowly reclaiming their places in the pattern. It reminds us that the web does not only tremble, it heals. To understand this web is to see the world not as separate parts, but as a single living system. Every drop of rain carries the memory of oceans. Every tree is a library of sunlight. Every animal's heartbeat is timed by the rhythm of others. In that sense, the earth itself is one great organism, and we are among its cells, capable of nurturing or harming the whole. If one day future beings were to trace the history of this age, they might see it as a moment of tension in that great web, a time when its threads were strained, stretched thin, yet not yet broken. And perhaps they will see, within it, signs of awareness, moments when the builders of cities remembered they were also children of the soil and began to mend what they had torn. Because in truth, the web is not something outside of us, it is us. It hums in our blood and breath, in the pollen that clings to our skin, in the water that fills our lungs and cells. The world's balance depends on it, as we depend on it in return. When one thread breaks, the whole web trembles. But as long as even a few strands remain, the pattern can be rewoven. It is a reminder whispered through every leaf, every wave, every living thing. Connection is not weakness, it is survival. Every living planet has limits, though they are not drawn on any map. They are invisible thresholds, lines that hold the difference between balance and collapse. For billions of years, Earth's systems have circled within those boundaries, shifting but steady, oceans regulating heat, forests storing carbon, ice reflecting sunlight back into space. Life evolved within this quiet order, learning the rhythm of a planet that knew how to heal itself. But now, the rhythm is faltering. The boundaries that once held steady are beginning to give way. Scientists call them planetary boundaries, 9 fragile points of balance that together define the safe space for life on Earth. They are not walls, nor laws, but delicate thresholds, the limits beyond which the planet begins to behave in unpredictable ways. Each boundary represents a vital part of the system that keeps Earth stable: the air we breathe, the water that flows, the soil that feeds, and the living diversity that binds them all together. The first is climate change, shaped by the carbon that rises unseen from factories, forests, and fires. For centuries, this boundary kept the planet's temperature in a narrow range, gentle enough for forests to grow and ice to form. But as carbon thickens in the atmosphere, the warmth it traps grows stronger. The line that once defined safety has already been crossed. The ice retreats, the seas rise, the air holds more heat than the world remembers. Next is biosphere integrity, the measure of life's diversity and resilience. Every species lost is more than a number. It is the weakening of the fabric that keeps ecosystems alive. The living world has endured mass extinctions before, but never one driven by a single species. The current rate of biodiversity loss far exceeds the boundary of stability. The web of life is thinning, and though it still holds, its threads are stretched. Then comes the nitrogen and phosphorus cycles, the unseen chemistry of growth. These two elements feed every living thing, cycling through soil, roots, rivers, and back to the sea. But modern agriculture has flooded the system with excess. Fertilizers run off into waterways, feeding blooms of algae that choke the oxygen from lakes and coastal seas. In the process of feeding ourselves, we have unbalanced the world's chemistry. Land system change marks another boundary. Forests and grasslands, wetlands and tundra once acted as the lungs and skin of the planet. They stored water, cooled the air, and cradled life. But human expansion has reshaped them into farmland and cities, shrinking wild spaces to fragments. The Earth's surface has been transformed so completely that the living patterns of landscapes no longer follow their ancient cycles. Freshwater use is another thread in the weave. Rivers are dammed, aquifers drained, and rainfall patterns shifted by a warming sky. In many regions, water that once ran freely no longer reaches the sea. The planet's circulation system is growing strained, and with it, the ability to sustain the countless lives that depend on every drop. Ocean acidification follows closely, the silent twin of climate change. As carbon fills the sky, the seas absorb it, turning slightly more acidic with every passing year. This boundary, once steady for millions of years, is now tilting. Shells weaken, coral skeletons dissolve, and the ocean's ability to cradle life grows uncertain. Another limit lies in the ozone layer, high above the clouds, the shield that guards life from the sun's ultraviolet fire. Decades ago, this boundary was breached by chemicals rising from human industry. But here, there is a glimmer of balance regained. Nations acted, ozone-depleting gases were banned, and slowly, the sky began to heal. It is one of the few boundaries we have crossed and then stepped back from, a quiet reminder that repair is still possible. The aerosol loading boundary is less visible, yet it touches the air we breathe each day. Tiny particles, soot, dust, smoke, float in the atmosphere, altering clouds, reflecting sunlight, and shaping rainfall. They blur the line between natural cycles and human interference. While their full boundary is not yet certain, their influence already touches the rhythm of monsoons and the clarity of skies. Finally, there is the introduction of novel entities, the human-made materials that nature never knew. Plastics, synthetic chemicals, microfibers, radioactive isotopes, each is a marker of modern life, yet together they are building a new layer in the planet's record. These substances accumulate in soil and sea, altering biology in ways still unknown. This boundary, too, has been crossed, though we are only beginning to understand its depth. Each of these 9 systems connects to the others. No boundary exists in isolation. When one falters, it pulls upon the rest. A warming climate dries rivers. Acidic oceans weaken coral reefs. The loss of forests intensifies, carbons rise. It is a chain of responses, a living feedback that loops endlessly, amplifying the strain. We have crossed more than half already. Climate, biodiversity, land, nutrients, and novel entities, each now beyond its safe limit. The planet still holds, but uneasily, like a structure leaning against the wind. Scientists describe this moment not as doom, but as a warning. The Earth is shifting from stability into uncertainty, and yet, even as we measure these boundaries, we remain part of them. Every choice, every invention, every seed planted or forest restored bends the curve of these thresholds. The Earth is not merely reacting to us, it is responding with us, adjusting, adapting, enduring. The boundaries remind us that balance is not permanent. It is a living state, something earned and maintained through care. They show that the planet's stability is both powerful and delicate, resilient enough to recover, but not infinite. One day, long after this age has passed, the Rocks and ice will record the marks of our decisions. They will tell of a species that walked to the edge of its planet's limits and began to see the threads that held it all together. And perhaps, in that record, there will also be signs that we learned to listen, that we remembered where those boundaries were drawn and found our way back within them. Far beneath the weight of time, the earth remembers everything. Every breath, every wave, every fleeting moment of existence leaves a trace, pressed into the planet's slow memory. For billions of years, each age has written its own chapter into the rock. Shells becoming limestone, forests turning to coal, creatures dissolving into stone. Now, as this age unfolds, the world is already writing ours. If future beings, perhaps millions of years from now, were to uncover what remains of us, they would find a story told not in words, but in layers. They would see a distinct band in the Earth's crust, marking a moment when the natural order changed its rhythm. Above it, something different would begin, sharp, metallic, artificial, the Anthropocene layer, the age of us. In that layer, cities would stand out first. Long after the last light fades, after glass returns to sand and steel corrodes to dust, their bones will remain. Roads will harden into strange fossils of asphalt, smooth and dark like veins of forgotten rivers. Bridges will collapse, yet their concrete foundations will persist, buried under the quiet patience of soil. Skyscrapers will crumble into mineral skeletons, still arranged in perfect geometry, the outlines of a vanished civilization frozen in rock. It will look, perhaps, like coral reefs once did, networks of hollow towers built by countless hands instead of countless polyps. Cities will become reefs of concrete and steel, housing no life but storing its memory. The fossilized shapes of pipes, rebar, and foundations will whisper of an age that moved stone and metal as easily as wind moves sand. Mixed within that same layer will be the more intimate traces, the remains of daily life. The fragments of glass bottles, bits of ceramic plates, slivers of phones and screens, even human bones will lie entombed among the remnants of machines. Yet they will not rest in natural soil, but in a sediment laced with something strange. Plastic. Plastic will be our most enduring creation. It resists decay better than bone, better than coral, better even than many stones. Future geologists may find entire strata of plastic-infused earth, layers shimmering faintly with color, each piece once shaped for something ordinary, a cup, a bag, a child's toy. Over time, heat and pressure will transform these fragments into a new kind of rock, a hybrid material that has never existed before. Some scientists already call it plastiglomerate, a mixture of melted plastic fused with sand, shells, and volcanic stone. It will outlast us by millions of years. Our machines, too, will fossilize. Airplanes buried in deserts, ships resting in seafloors, satellites falling from orbit and settling quietly into the deep ocean mud. Their metals will corrode, their engines turn to dust, but their shapes will remain faintly recognizable. A layer rich in alloys, radioactive isotopes, and chemical residues will tell of an age when intelligence reshaped matter itself. Even our energy will leave fingerprints. The burning of fossil fuels has already altered the planet's chemical story. Carbon atoms, once locked deep underground, are now scattered through every living thing, marking this time with a unique isotopic signature. If someone, far in the future, were to measure the ratio of carbon in the rocks, they would find it sharply different, a moment of sudden imbalance in Earth's long history. They might see it as the signal of an event, much like the thin iridium line that marks the asteroid impact which ended the age of dinosaurs. And yet, not all marks will be heavy or tragic. Some will be subtle, even beautiful. The remnants of gardens encased in permafrost, pollen grains sealed in the silt of rivers, seeds still capable of life. Beneath volcanic ash or buried by the tides, they may wait in silence, holding the memory of what once grew. The planet will not forget the color of flowers, nor the scent of forests. There will also be echoes of sound and light, though they will not fossilize, they will linger in subtle ways. The radiation from nuclear testing will form a thin, glowing signature in the rock record, a silent pulse marking our brief mastery of the atom. Traces of rare metals from electronics, gold, cobalt, lithium, will form strange mineral seams, unnatural concentrations that will tell of an age obsessed with power and connection. When the Earth's crust is cut open in some distant epoch, the record will be unmistakable. A sudden bloom of complexity, a spike in metals and plastics, a drop in biodiversity, the signature of warming. Then, perhaps, a quiet return to balance as the planet heals, the way it always has, a world after us, still marked by us. The rocks will remember the outlines of our ambition. They will record the years when we mined the deep, burned the old forests, and built monuments of glass and wire. They will also remember the moments of restoration, the seeds we stored, the species we saved, the forests we replanted. Both the harm and the hope will be etched together, inseparable. The earth is vast and patient. Long after human voices fade, the planet will continue its slow work of renewal. Wind will sculpt the ruins, rivers will smooth the stones, and mountains will rise from ancient plains once again. The traces of us will sink deeper, layer upon layer, until they become part of the bedrock of time. In the end, what remains will not be the noise of our existence, but the silence that follows, a silence filled with memory. If someday someone were to hold a piece of that stone, they would find inside it the story of a species that once changed the world. They would see beauty and sorrow, brilliance and recklessness, all pressed into a single thin line in the planet's history. And as they brushed the dust away, they might whisper softly, "Here they were." The earth still breathes. Beneath all the noise, beneath the hum of cities and the pulse of engines, life continues to whisper its quiet defiance. Though the balance has been shaken, the planet has not forgotten how to heal. It simply waits for space, for stillness, for the gentle return of time. And in some places, that healing has already begun. Across the world, small acts of restoration are unfolding like green shoots breaking through the cracks. They are not loud, they do not seek recognition, yet together they form a quiet resistance, a patient movement of life reclaiming what was lost. In the Scottish Highlands, the wind once carried the cry of wolves and the shadow of great forests. Centuries of deforestation and hunting left the land bare and quiet. Now, humans are learning to step back. Hillsides once grazed to stone are being allowed to grow wild again. Birch and pine are returning, and with them come the insects, the birds, and the deer. Rivers are reshaping themselves, naturally, no longer forced by human hands. Beavers, reintroduced after centuries of absence, are building dams that slow the water, creating pools where fish and frogs return. The landscape begins to remember itself. This process has a name: rewilding. It means giving space back to nature, not managing it, not controlling it, but trusting its own rhythm to return. It is not about recreating a past world, but allowing a new one to emerge. Across Europe, entire corridors of wilderness are being restored. Wolves have crossed from Italy into France and Germany, following ancient migration paths. Lynx prowl once again in the forests of Spain. Bison graze in fields that have not seen them since before recorded history. Even in the Netherlands, one of the most densely populated countries on Earth, wetlands are being rebuilt, letting tides and floodplains move freely again. Where machines once ruled, reeds now sway, and the sound of wings fills the air. The ocean, too, has begun to find its breath again. In the waters off the coast of Mexico, giant marine reserves now protect whale sharks, manta rays, and turtles. Fishing is forbidden there, allowing ecosystems to recover from centuries of depletion. Within a few short decades, coral reefs once pale and lifeless have begun to show signs of color again. Schools of fish swirl through them in shimmering ribbons, and the slow dance of seagrasses returns to the ocean floor. The same story is unfolding off the coast of Kenya, in Indonesia, in the distant waters of the Pacific. Wherever humans give the ocean stillness, it begins to heal. The sea does not need permission, only time. Even on land, species once thought gone forever are finding their way back. In the dense jungles of Vietnam, the saola, a small and mysterious forest antelope, has been sighted again after decades of silence. In Rwanda, mountain gorillas, once teetering on the edge of extinction, are increasing in number as the forests are protected. In North America, bald eagles soar over lakes that once poisoned them, and in India, forests have grown around the homes of tigers, again turning fear into coexistence. These moments are not miracles, they are reminders of how quickly nature answers when given the chance. Sometimes, the healing begins even without our help. In the exclusion zone around Chernobyl, where humans fled after the nuclear disaster, forests have reclaimed the empty villages. Wolves, elk, and lynx roam through the ruins. Birds nest in the frames of abandoned buildings. The soil still holds radiation, yet life continues, wild and free, adapting in ways we are only beginning to understand. There is a lesson in that quietness. Even silence can heal if given time. Not every recovery can erase the damage done, and not every ecosystem can return to what it once was. But the direction matters. Each seed planted, each coastline protected, each species returned, all are threads in the slow mending of the Earth's tapestry. In Costa Rica, rainforests are expanding once more. Once devastated by agriculture, the land has been reborn through careful protection. Now, sloths and toucans drift through the canopy, and rivers flow clear again. Local communities, who once relied on cutting down the trees, now find a living in keeping them alive. Tourism built on wonder has replaced industry built on loss. It is proof that preservation and prosperity can grow side by side if nurtured with patience. Elsewhere, scientists and farmers are working together to reintroduce wildflowers to fields long silenced by monocultures. The hum of bees is returning. Pollinators, the tiny architects of abundance, are finding their way home. Even urban areas are changing. Rooftops have become gardens. Abandoned lots have turned into sanctuaries for birds and butterflies. Cities that once consumed nature are learning to live alongside it. And in the far north, where melting ice has revealed forgotten tundra, new life is creeping upward through the thaw. Lichens and mosses spread first, softening the ground. Then come the small flowers, and soon the insects that feed on them. Step by step, the land begins to breathe again. The Earth's recovery is not a straight path. It does not happen evenly or quickly, but it is steady. Life has always known how to survive chaos, and in this age of imbalance, that knowledge has not been lost. The world resists quietly, in roots, in wings, in the unseen labor of soil and sea. Somewhere tonight, a forest is growing where a field once stood bare. Somewhere, the tide is returning to a bay left empty. Somewhere, a bird calls in a place where no bird has sung in years. The planet has not given up. It only asks for stillness, for patience, for time to do what it has always done. And if we listen closely enough, we might hear it. The sound of quiet resistance, steady as the heartbeat of the world, reminding us that even silence can heal. There is a quiet truth about the story of life on Earth. Extinction is not a sentence carved in stone. It is a slope, a movement, a rhythm that can still be slowed, even reversed. What we face now is not fate, but momentum, the rolling weight of choices made over centuries, gathering speed as it descends through time. But just as it was built by hands and habits, it can be steadied by them too. The clock is still ticking, but it has not struck its final note. Every system on this planet carries balance within it. Oceans can clear, forests can regrow, and climates can stabilize, but only if given space to do so. It is not magic, and it is not faith. It is math, a matter of scale, of pressure, of the simple physics of cause and effect. A few degrees, a few choices, can tilt the curve in one direction or another. Scientists often describe tipping points, moments where a system shifts from one state to another so quickly that recovery becomes almost impossible. Ice sheets melting faster than snow can rebuild, forests drying beyond the point of regrowth, coral reefs bleaching until the last living cell disappears. But alongside these tipping points are what some call turning points, thresholds where action, even small, can reverse a path before it locks into permanence. We are still within that window. In the Arctic, ice still returns each winter, fragile but present. Forests in South America still breathe, their roots clutching at the last wet layers of soil. Coral reefs, though fading, still release their eggs into the current each year, hoping to find safe water to begin again. These are not endings, but pauses, moments suspended between loss and renewal. When people speak of saving the world, it can sound too large, too heavy to hold, but the truth is quieter. The future of the planet is built from millions of small, tangible decisions that ripple outward. A tree left standing, a river allowed to flow, a machine turned off an hour earlier. Each one shifts the equation. Each one buys time. Even temperature, the simple measure of heat and light in the air, tells a story of possibility. Scientists once feared that warming would spiral beyond control, but data now shows that every fraction of a degree matters. If global temperatures rise by 2 degrees, the losses will be immense. If held to 1.5, countless species, reefs, and ice fields could remain. Half a degree may sound like nothing, but in planetary terms, it is everything. It is the difference between coral and skeleton, between storm and season, between what lives and what remains. Around the world, communities are learning this quiet arithmetic of hope. Cities are redesigning themselves to breathe more gently. Solar panels bloom like fields of metal flowers across deserts. Wind turbines turn above seas, once thick with oil rigs. Nations are beginning to protect more of their land and oceans, setting aside spaces for the living world to simply be. The math of survival is not just about emissions or energy. It is about connection between choices and consequences, between what we take and what we return. When forests are protected, they pull carbon from the sky. When oceans are allowed to rest, fish populations recover, feeding communities again. When soil is cared for, it stores rain and supports life. Nature rewards balance with abundance if we remember to keep the equation fair. And there are signs that we are remembering. In the Pacific, whale populations are rising again, their songs once more echoing through deep water. In Europe, brown bears and wolves walk ancient routes that had been silent for centuries. In small farms across Asia and Africa, regenerative agriculture restores tired land, turning fields into living mosaics. Each story is different, yet together they share the same pulse, proof that change, even after damage, is still possible. Time moves in only one direction, but life does not. Life adapts, shifts, finds cracks of light in the darkest soil. The sixth mass extinction, if it comes to pass, will not be a single moment. It will be a slope, and slopes can be slowed. To save one species is not to save the world, but it is to change the sum of it. Every living thing saved slows the clock. Every reef that endures, every forest that grows again, lengthens the space between now and silence. We cannot undo all that has been done. The earth of the past will not return, but a different future, one still rich and alive, still within reach of wonder, can be shaped by the hands that hold it now. In the end, the planet asks for no perfection, only participation, to notice, to act, to let life continue its patient work of renewal. Somewhere, the last seeds of a tree fall onto open ground. Somewhere, a river flows clear again after decades of waste. Somewhere, in a quiet stretch of sea, a coral polyp drifts, searching for a place to begin. The world has not stopped trying. The window is still open, wide enough for light to pass through. What follows depends on whether we step through it or simply let the breeze fade away. The earth remembers, even when the surface is changed, even when oceans shift and mountains fall, its memory runs deep. It is written not in words, but in layers. Each stratum of rock, each trace of ash, each fossilized breath tells a story that stretches farther than any map or history can reach. If the planet could speak, its voice would be slow and patient. It would tell us that it has been many worlds before this one, colder, hotter, emptier, and full again. It has died before and lived again. Long before the first humans walked its surface, the earth endured cataclysms that remade everything. There were ages when the air froze solid and turned the planet into a mirror of ice. Ages when volcanoes poured fire into the sky, darkening the sun for centuries. Ages when oceans turned to poison and the horizon burned with storms. And yet, from every ending came a beginning. Life retreated, adapted, transformed. It found new shapes, new paths, new voices. The story never stopped, only shifted its tone. In the deepest rocks, the fossils of trilobites still lie curled, the first eyes that ever saw sunlight. In the limestones of ancient seas, coral ghosts preserve the architecture of vanished reefs. In amber, insects remain sealed mid-flight, their wings caught in the honeyed paws of time. And in the dust beneath our feet, the bones of creatures that once ruled the land whisper of both triumph and silence. Each layer carries a record of collapse, but also of return. After the great dying, when almost all life perished, the ocean stirred again with tiny cells of green. After the asteroid that ended the reign of the dinosaurs, small mammals began to scurry through the ashes, fragile but determined. From those survivors came everything that would follow: forests, songs, intelligence, memory. It seems the Earth's long story is not one of destruction, but of resilience. Life has never been a straight line. It has always been a circle, drawn again and again upon the same ancient page. And now we stand within that circle. The signs of change are all around us, in the warming seas, the shifting skies, the vanishing forests. We have traced the patterns of the past and recognized the same pulse rising again. Some call it the sixth extinction. The name carries a kind of gravity, a recognition that our age may one day form another layer in the rock, another turning of the page. But there is something different this time. The force shaping this change is not a volcano or an asteroid. It is us. We are both the storm and the witness, the cause and the caretaker. No other species has ever held that power or that choice. If we are part of the sixth extinction, we are also part of its story of survival. Already, the earth responds to what we do. When forests are allowed to regrow, rain returns. When oceans are given rest, coral begins to bloom again. When species are protected, their numbers rise, their songs return to the wind. These are small gestures in the vastness of time, but they matter. They alter the story, however slightly. They remind the planet that its memory is still being written, still alive. Perhaps, millions of years from now, when the seas have shifted and continents have drifted apart, this age will leave behind a faint line of stone. Future eyes, human or not, might look upon it and find the trace of our presence. They might see the marks of our cities, the imprint of our tools, the shadow of our choices, but they might also find signs of recovery, seeds, shells, bones, the beginnings of whatever came next. The Earth's patience is longer than ours. It measures time not in centuries, but in cycles. Its memory stretches beyond imagination, and yet it holds space for what is still to come. Every breath we take, every sound that moves through the air, is part of that ongoing remembrance. We are made of it. The calcium in our bones was once part of ancient shells. The iron in our blood was born in the heart of stars. The water that cools our skin has passed through countless lives before us. In that sense, we are not separate from the Earth's memory, we are its memory. The continuation of its pulse. The future remains uncertain, but uncertainty has always been the birthplace of possibility. The same energy that drives extinction drives renewal. The same sunlight that warms the oceans also feeds the leaves that pull carbon from the air. The planet still contains within it everything it needs to heal. It only asks for time and a chance to breathe. So tonight, as the world turns quietly under the weight of its history, it continues to write. Wind moves across the grass, rivers carve new paths through the soil. Somewhere in the deep sea, a creature glows for the first time, unseen by any eye. Somewhere, a seed wakes beneath the snow. The earth endures, not because it is unbreakable, but because it remembers how to begin again. And so, beneath all our noise and worry, the planet still breathes. Beneath us, the night is still alive, and for now, we still have time.